All right. Hello. Hello. Welcome again to this thing. Part part 21. That's something. So I checked, and so far the playlist for these videos has got a total of 94 hours, 38 minutes, and 58 seconds of video in it. So that's nearly 4 days worth of continuous video. On this stream, if we get to 5 hours and 21 minutes and 2 seconds, we're going to hit the 100-hour mark. So that's exciting, isn't it? Maybe that's going to happen. But until then, what are we doing? Well, I am writing a WebAssembly interpreter in Ruby. I'm doing that 90% to have fun, 8% to demystify WebAssembly for myself, and 2% to just let you see how I do stuff, basically. These are some reminders for myself. I'm doing this mainly to have fun, and so it's more important that I do have fun than that the resulting interpreter is functional. I want the code to be correct, even if that comes at the expense of it being fast. I want it to be clear, even if that comes at the expense of it being clever. I'm trying to do it in pure Ruby. I'm trying to do it with no dependencies. That's what I'm doing. Just telling myself what the point of this is. Okay, so as always, before I get stuck in, I'm just going to do a brief retro, which is just an opportunity for me to think about what happened last time, and how I feel about that. Last time actually went pretty well. I did get several more tests passing. I implemented memory.grow, I implemented type definitions, and the ability to refer to type definitions. Got block comments working in the S-expression parser, so that also made another test pass. The bulk of what I did was cleaning up the abstract syntax parser significantly. So it was previously a bit all over the place. Last time I gave it some love and sort of tidied it up a bit and sort of brought some structure to it, more than tidying, sort of like imposed some structure on it so that it's not just a miscellaneous soup of stuff. It's actually a little bit more structured and meaningful now. So that was good, I think. But it's pretty tiring to keep working on the abstract syntax parser. Parsers are not the interesting part of implementing a programming language, so I'd rather be doing something more fun and more immediately rewarding with respect to making the test pass, so actually feeling like I'm implementing more of the features of the language rather than just continuing to deal with its syntax. But, firstly, I feel like I've hit a point in my implementation of the features of the language where actually the parser is sort of the limiting factor, because there's stuff I need to be able to parse or information I need to get out of the parser that it currently doesn't support. And so it's just a bit tiring to sort of feel blocked on a part of the project that isn't the most interesting part. I would rather be working on implementing new instructions, basically. But all that being said, I'm sort of conscious that I can't really stop working on the parser yet, because I've been procrastinating for weeks about adding the identifier context to the parser and sort of unshackling the interpreter from having to know about identifiers. And I've been putting that off and putting it off. Why is that? I'm not really sure, but I think the main reason why I haven't done it is fear. And specifically, I'm frightened that there's sort of latent debt in the parser that's going to make it too hard to add new features or improve the existing implementation. In particular, the way that parsing and unfolding of expressions is separated at the moment sort of feels wrong and is causing duplication of knowledge and duplication of work and confusing error messages, because when unfolding, effectively unfolding happens as like a separate phase inside the parser. So we will sort of try to well, I mean, initially it was a completely separate phase where we recursively unfolded an expression. Now it's sort of somewhat better integrated in that we sort of incrementally unfold expressions as we find them. So it's getting less bad. But there are still sort of confusing error messages caused by when unfolding fails, when it hasn't recognized some new instruction that we haven't implemented yet. I don't get an error from parse expression or parse instruction saying I found a foo instruction, I don't know what to do with it. Instead, what I get is a much more confusing error where that expression has tried to unfold it as if it was like a nullary instruction that doesn't take any immediate arguments, and then that's moved things around in such a way that the expression has become syntactically invalid. The argument's been moved before the immediate argument has been moved before the thing that it's an immediate argument of, and then that's been interpreted in instruction position, and like it's just not very good. So that worries me and frightens me a bit. I also suspect that there are lots of sort of hidden patterns in that parser that I haven't spotted and extracted yet. So I think my goal for today is to sort of conquer that fear and at least get myself ready to tackle the identifier context, if not start doing it. I think if I can get to a point where I feel like the only reason why I haven't done that yet is because I don't need to do it, that would be great. Whereas at the moment, I feel like I'm still a bit too frightened to touch anything in that parser because I'm not really confident that it works correctly. And that's not a good position to be in. So anyway, that's enough chat. That's enough big fear. Let's switch over. As always, where are we? Looks like the tests are passing. That's good. I haven't left it at a point where that's not true. I've got some stuff. I'll just clean up my to-dos here while the tests are running. So yeah, we've done nested comments. We made a test pass. Oh yeah, there's this spec test import. So like the idea that the host environment provides this spec test module that's got like native functions that can do things like print to std out and stuff like that. So yeah, I could have a look at that. Make read until stop automatically. Read until and repeatedly don't discard the terminator. Yeah, we did that. Account for trailing label correctly in read until. Loop foo, end foo. Did we do that? I feel like that might have got done. What does read until say? Oh no, it doesn't. We have to read until else. Okay, yeah, I don't think I've done anything about that. Extract a parse index helper and probably loads of other ones. Yeah, I think this is some really low-hanging fruit, is just to go, there's still lots of duplication in the code. Oops. Still lots of duplication in the code here. And I think it would be really beneficial for me to just take a pass through this and just pull out anything that is repeated, just so that there's less duplication and we can give names to things and it'll make this whole thing easier to read and easier to understand. Introduce a nice module object in the interpreter to wrap the function table definition. Okay, well that's not a parsing concern. Oh yeah, we dealt with the lack of an expression AST node by saying there shouldn't be one. Do we really need terminated by? Yes, I think we do. Push all the read your own opcode inside each parsing method. Yes, rename with input to read list. Yeah, we did that. Yeah, and then this, of course, is the thing that I've been kicking. The can I've been kicking down the road is introducing an identifier context. So fine. Oh yeah, and I did this type definition stuff. I'm going to leave that because otherwise we've just got this one undone thing that doesn't really make sense on its own. Okay, yeah, so this only call unfold unfolded instructions if possible. I did actually do that. And then this is sort of the thing that I haven't done, which is somehow concentrate the knowledge. I mean, effectively, the main thing I'm worried about here is that you have to, if we look in unfold, this has to know about the arity of all of these instructions. So unfold has to know that i32 const and i64 const and f32 const and local get and local set and global get and all those things take a single argument, and that's sort of baked in here, for example. But then when we look at parse instruction, well, I guess it'll be parse numeric instruction in that case. Yeah, so now here const, we know that we have to read a single argument here. So that knowledge is, and that applies to basically every instruction that we know how to parse at the moment. It sort of has to be treated correctly in unfold, and then it has to be treated correctly somewhere inside parse instruction, and that feels like an obstacle to maintaining this in future. So either I need to unfold and parse as like a single operation, or I need to find a way to sort of centralize this knowledge about how many arguments, how many immediate arguments each instruction has, so that if unfolding and parsing do have to be like separate in this way, then it should be possible for both of them to refer to the same source of knowledge rather than having to just duplicate that knowledge. Abbreviations. Oh yeah, I mean, all of this is just, I think I can ignore all of that for now. Float.rb, can't even remember that guy. Okay, all right. So I think I probably want to start with some sort of fairly simple stuff, extractor, parse, index, helper, well, and probably loads of other ones. I think what I'll do is just take a pass through the code and just look for things that I can extract and give names to and remove duplication, and then I think that'll go quite a long way to actually cleaning things up and making them easier to understand and to maintain. I mean, ultimately, this is where I'm trying to get to. I think all of the rest of this stuff is sort of optional, but I definitely need an identifier context. I sort of do want to look at either combine parsing and unfolding, or find a way for them to share knowledge of static instruction arity. So I think this is probably my plan, is like do a bunch of cleanup, extract some helpers, e.g. parse index, do something about the split between parsing and unfolding, and then I think if I can do that, get to the point where there's not a lot of code duplication and I feel more confident about how the sort of the structure of the parsing is working, then I think I'll be more willing to move on to trying to stick the identifier context in there. And I don't know how hard that's going to be, but I suspect the answer is a bit fiddly. And then, I've got these. I still haven't had a chance to look at Chris Zetter's pull request. I'm sorry, Chris. I am going to get to this. But I suppose you're suffering here from the fact that I'm not working on the interpreter at the moment. I've just been stuck in the parser for the last few streams. So unfortunately, I'm going to probably carry on like that. So, okay. All right, so I can run the test there. Let's just have a look through here. What I'd like to be able to do is sort of scroll through all of this without seeing anything that makes me go like, oh, that's not right. And at the moment, and when I looked over this earlier today, I sort of saw lots of things that made me go, oh, that's not right. So, I mean, here's an example of that. Like, I think this is slightly weird. It's weird that this is not like regular. We sort of call parse integer and then we sort of optionally call it again. I don't really like, given that memory is inside a list, it feels like what we need to try to do is read the whole rest of the list and then interpret it in terms of, yeah, what is it? Have we only got the minimum size or have we got the minimum maximum? So I think, I mean, this isn't important. This is just the first thing that I happened to see just now. But I think what we should be able to do here is say like repeatedly read. Well, in fact, we can repeatedly parse integer, I suppose. So do something like that. And then this is going to return an array of some size. And then I can sort of say, well, what is it? Is it in... If it's just if it's just a single item array, then that means we found the minimum size. If it's a 2-item array, that means we found the minimum size and the maximum size. And if it's anything else, then we'll get a pattern match failure here. So I think that's probably what we want. Like, rather than allowing there to be unread stuff after memory here, I think we should be able to say, if there's not one of these nested data lists, which, you know, contains a load of strings that we're going to concatenate together, then I just want to read everything else and treat it as an integer, and then this will raise an exception if the thing that we're trying to read isn't an integer, I hope. Maybe it won't. It's going to call 2i, so I guess we're sort of at the mercy of what the semantics of Ruby 2i are there. So no, that's another thing to think about. But in any case, I feel like this is just a small example of what I'm talking about. I think that this is a little bit more expressive and regular than what was there before, because this is kind of more explicitly saying everything that comes after memory is an integer, and then there can either be one of them, in which case that is the minimum size, or there can be two, in which case it's the minimum and the maximum. So I think that's the sort of thing that I would like to be able to do more of. And in fact, I guess this, you know, this is the kind of thing that's a reasonable candidate for being extracted as well, because this is just sort of parsing the, I don't know what you call that, parsing memory size or something like that. Could really, what I want is, as far as possible for each of these parse methods, to really just be a couple of lines. And if there's anything more complicated that they need to do, then they do it by calling some other method. So as far as possible, this starts to sort of resemble the grammar. And it says that, well, if you want to pass this memory instruction, then you've really got two options. Either you've got the data after it, or you've got the minimum maximum size. And that's sort of documented in the names of the methods that we're calling, the helper methods. And it also makes each of these methods smaller, which I think overall is a win, even though obviously it means you get more methods, which can be a little bit overwhelming. But I think for the purposes of debugging and extending and stuff like that, it is better to have these be lots of small composable pieces rather than larger pieces that are sort of more difficult to understand. So let's say use repeatedly to read minimum and maximum memory size. I think that's okay. I don't really have anything to say about that. I mean, I just spoke about it for 5 minutes, but oh yeah, let's just say this makes it clearer that memory is followed either by data or many integers, actually only one or two. We'll fail faster if by trying to parse everything after memory as an integer in this case will fail faster if there are more than 2 values, or in principle, if not in practice, given how tolerant to I is, if any of them is not an integer. Okay. So yeah, I think we can pull out, both this is the kind of thing I'd like to do as well, is like both arms of this conditional, like this little expression here, I think this could just be parse memory data. Let me stick that in there. And then this just becomes string equals parse memory data. Well, actually, I think what I want to do is, because just looking at these, when you're parsing memory, the first thing you do is read the memory atom. If you're parsing a table, the first thing you do is read the table atom. So I think probably what we want here is, instead of this read list, I think that we want this to be read the data atom, and then we repeatedly parse strings and then we join them. So like that's the thing that once you're inside this memory data list, this knows how to read it, and then up here we just need to arrange that we're inside it. So whereas previously I was doing this read list starting with data, which automatically throws away that first atom, I think this allows this helper method to be a bit more regular and predictable. I mean, I don't know whether this is a good thing yet, because maybe this design of having each of these things read, their opcode or whatever you want to call it at the beginning is actually silly. But at the moment, that's how it works. And so at the very least, this is what we need to do to make it consistent. So if I consistently say we're always going to read the opcode at the beginning of the little helper, and then that means we need to just dive into the list but not consume that starting opcode. So here instead of can read list starting with and then read list starting with, we're just using can read list to make a decision, but then it's actually parse memory data that does the job of throwing away that starting thing. There was a memory test, right? Let's just run that. Okay, that looks okay. In fact, why don't I do my usual thing of having a third tab for running those in while I prepare my commit. So that's just extract parse memory data helper. Let's say the convention is for parse methods to begin by reading their own opcode. In order to do this here, we need to arrange for the caller to use read list without starting with argument, so that the opcode is left alone for parse memory data to consume. I'm not necessarily confident that this is the right design for parse methods, but it's how they all work at the moment. So I'm trying to be consistent, if nothing else. Hi, Chris. Thank you for joining. Yes, I'm glad that you're enjoying watching this. And as I said before, I don't know if you were watching, but I already apologize for the fact that I've been stuck in the parser for several sessions now, and so haven't. As soon as I go back to the interpreter, looking at your pull request suggestion is going to be top of my priority list, but I'm still trying to extricate myself from this world of case in statements. Okay, I seem to have not broken anything there, so that's a relief. I think I can do the other half of it now, right? So this thing, I think this can just more straightforwardly be sort of parse memory sizes. What do I want this to return? Like, I think up here, I'm going to do parse memory sizes. For now, I'll just return an array. Something like that. And then this needs to be, and now we're being more explicit about what the default is, right? If you don't provide a maximum size, then we get nil here. So something like that. So that's actually slightly longer. Excuse me, because previously the pattern match was just assigning these local variables, and we didn't have to be explicit about the fact that maximum size is nil here. But maybe that's better. At some point, I need to get my head around the fact around whether or not I want to be using the sort of pattern match syntax for destructuring. But that's what I've been doing so far. So again, I'm just going to be consistent about that, absent any better idea about how it should work. So what did I say? Extract parse memory sizes helper. I don't have anything else to say about that. But so the point of doing this was that now this is more the shape of what I want, right? It's like, how do you parse one of these memory directives or fields or whatever they're called? Well, you read the memory atom, and then based on whether the next thing is a list starting with data or not, either we drop into that list and call parse memory data, or we just parse these memory sizes, which are then immediately following the memory keyword. So that, to me, that feels like it's easier to understand what's going on there. Okay, so I sort of did that almost as like an example of the kind of thing that I would like to do, just to get this. Again, I know I'm sorry, it's not particularly interesting to watch or for me to do, but I feel like I do want to get this. I want to get this code in order before I start doing something difficult, which is what I think the identify context is going to be. So I've alighted on this because this is an obvious point of, each of these is nicely calling a helper. This one doesn't live in a helper. So I think it probably should be, let's call this parse unsupported assertion. And now where do I want to put that is the question. So I've got parse command and then parse module invoke assert return unsupported assertion. Okay, so I guess maybe here after assert return, because that's, that's where those methods live. Okay. So that's not, that's not very mind-blowing. And I will give it let's keep the test running, but I'll give that the length of commit message that it deserves. Extract parse unsupported assertion helper. Okay, that's looking okay. Oh, all right. So, I mean, I think this is what I'm going to do is just take a pass through this file and stuff that bothers me, just get stuck into it and try and if it's just a question of extracting stuff like that, then I'll be happy. This is a little bit annoying, isn't it? Again, I think it would be nice if I could pull these pieces out. It's going to be a bit inconvenient because of all these local variables. I mean, I can fix that for now by sort of sticking this in both arms and say like, well, do your thing, and then we're just going to return the module. And now I think there are two sort of self-contained What are the names of these things? Because I do feel like open a browser. So if we look in the WebAssembly standard, like what's the collective noun for these parts of a module? Text format, modules. A module consists of a sequence of fields that can occur in any order. All definitions and their respective band identifiers scope over the entire module, including the text preceding them. Oh, that's frightening. I hadn't read that before. All definitions and their respective band identifiers scope over the entire module, including the text preceding them. So this isn't what I wanted to think about right now, so I'll come back to that. But that's definitely gonna be relevant when I come to thinking about the identifier context, because that means that if you have a function definition or a type definition or any other kind of definition that appears at the module level that binds a name, then you have to be able to dereference that name even if the reference to it occurs earlier in the module. Okay, well that's annoying. Anyway, that's not a problem yet. What I was looking for was the word field. So I think I'm going to undo what I did there. I think what I would like to do is have some helpers here. Like, pull these out and then make this something like, well, assign the fields inside this conditional, basically. And I mean, maybe there could be a helper to read the fields, but I think if all it's doing is checking to see what the next thing is, and then if it's binary, we say like parse binary fields, and if it's not binary, we do parse fields, well, parse text fields, I suppose. So yeah, that makes sense, doesn't it? Oh, and then I was just like, where was I going with that? Where I was going with it was that then this would just be fields. So this kind of stays essentially the same. I guess we lose all these local variables. They kind of belong to this, right? Because this is where these actually get populated. Because this doesn't even bother to do anything with them at the moment because it's not implemented. So yeah, let me just finish what I was doing there. So this is parse binary. So that doesn't do anything useful yet. Whereas that lot does do something useful. Oh dear. That didn't go very well, did it? So this needs to return... well, I just need to stick all those in a hash, right? So all those local variables that are intended to feed the module constructor, just return them all there. And then I guess I need, although I very blithely just left that one alone, it does actually also need to return something like this, but it's going to return, like, for the moment, the dummy, because memory is nil, tables is empty, globals is empty. Oops. Types is empty. So I think that's probably okay. I can probably get rid of that blank line. So yeah, this is, it's sort of along similar lines to what all these other things are doing, right? They're sort of peaking once and making a decision, and then they're calling something else. And in this case, it's just that, I mean, I guess I could I could inline this module.new in both arms of that conditional, but I think being able to name fields like this and then have it in a local variable is probably helps to make that a bit clearer. So I'm just going to stick with that for now. Okay. Extract parse binary fields and parse text fields. Helpers. Okay, it's looking good. All right, so I'm feeling more happy with this now. That parse module was actually quite long before, but it feels like it's you know, more under control now that I've pulled those things out. So that's good. I think this is okay, because that, again, that is just dispatching off to these other functions, and it's just collecting the results up in a particular structure, which seems right. I mean, looking at this, it occurs to me, is it right that we keep these segregated, or should these just be added onto a list of fields rather than being separated out into different flavors? It does say a module consists of a sequence of fields that can occur in any order. If I go to this structure section is essentially about abstract syntax. So in here I should be able to find out what they think the abstract syntax of, well, modules, I guess, looks like. Programs are organized into modules, which are the unit of deployment, blah, blah, blah. A module collects definitions for types, functions, tables, memories, and globals, imports, exports, data in element segments, or a start function. Okay, so in the abstract syntax they're providing here, all of these things are segregated. So it's not just it's not a list of fields, it's like separate. This is like a record here. This thing in curly braces is like a record, and then each of these is like the name of the field in the record. So there's a field called types that's a vector of function types. There's a field called funcs that's a vector of functions, and so on. So I think what I'm doing here is correct, basically, or at least it's what the spec says to do, which I don't have to do, but absent any opinion, which I don't really have at this point, I'd rather do, you know, what they're expecting. Okay. So parse invoke, that looks all right. Read the opcode, read the name, parse the instructions, build the node. Oh, this one's a bit more messy. Yeah, so this is a bit, there's several, you know, we're indented several levels here. There's one thing going on here that is really just, I'm pausing because I'm realizing that we always go into a list here. So actually this can read list thing is a little bit redundant, because here we go into a list and here we go into a list. So I think really what we could do here is say read list, given that we always read a list. And then there's this float opcode nil. I think what we're really, you know, there was this was kind of, I understand why I did this, but this is kind of clumsy. What I can do here is just peek. So I can say if peek in, or I guess I can do, what do I normally do? Do I do an if, or should this be a case? Yeah, I kind of use case there. Again, I think I've been a little bit all over the place with this, but let's say case peek in, if it's one of these, or f64.const, then that's actually inverting the sense of this conditional, isn't it? Because it was asking if it was nil before. So it's kind of this way around. So this becomes, well, I guess here we can read into opcode. Well, read through. Again, I don't know if I really want to be doing this, but this is what I've done so far, is when I'm expecting to read something, I sort of do a pattern match and then I save the result somewhere. So this is float opcode. And then bits equals blah. And then there's a sort of else read list down here. Right, which I've now... Well, in fact, both of these... Yes. Sorry, that was the point. Both of these read lists go away. And this just becomes case peak, blah, blah, blah. So let me just check and see if that's broken anything. Okay, that's looking hopeful. I mean, ultimately, what I would like to do actually is just pull out this part. Because this feels like it's doing something. You know, again, it starts by reading the opcode, and then it makes a decision and it returns either this NaN expectation or it returns a const instruction. But maybe I'll commit this. So what is this? Always read list inside pass assert return. This reduces the duplication of read list and makes it clearer that we're always entering a list and making a decision based on whether the opcode indicates a float constant. Okay, and then I think I could just pull out this bit. So if I called this parse float expectation, yeah, because all we're doing here is assigning expecteds, right? So I was just trying to think whether we need to do anything else there, but I think it's I think I can just say I start doing this and then I realize I could have typed it more quickly. Okay, so I think that makes sense, just to pull out that branch of it that says, well, we're expecting a float of some kind, and it's either you're going to have to evaluate an expression to find out what kind of float it is, or it's one of these special expectations. All right. I realized that it was previously if peak in, so I haven't been very consistent there. I'm sorry, but I'm not so bothered about code style things like that at this point. It's more about the high level organization of this code and making it more tractable. And then if I need to, run Rubacop over this to make me either say if peak in or case peak, then so be it. I'm more interested in things that something like Rubacop wouldn't be able to pick up on because they're a bit more high-minded than that. In fact, I think there's really very little benefit to calling this float opcode, so let's just call it opcode. Okay, I think that's probably good. So this is just extract parse float expectation helper. Okay, so we are making progress. I'm kind of moving onwards, actually starting to get somewhere. Parse unsupported assertion. Oh yeah, I just wrote that. I wonder if it's worth pulling this out. It might be. I think then that would, if this was just parse expecteds, then this could tighten up nicely. I think that's okay, because I think that's worth doing, because this is kind of a little bit deeply nested, and so I think having this separately, giving it a name, and showing that it's just, we read assert return, we read the invoke action, command, whatever it is, inside the assert return, which I don't think this is the only... Is that the only form it can take? It doesn't really matter for the purposes of this, but now I realize I don't actually know. Oh, it's in interpreter, not test. Yeah, this can actually be any action there, which is either going to be invoke or get. But yeah, I haven't worried about that yet, so I won't start worrying about it now. Yeah, my point was that I think this makes it clearer what the high-level structure of assert return is, and then all of the gory details are hidden inside these helpers. Looks good. So this is extract parse expected helper. Okay, that's looking healthy. All right, I'm sort of happy to leave this as it is, because this is just making a decision and then returning. Well, I mean, it does end up calling out to parse float here, but basically it's just returning the right kind of thing. So that feels, that feels defensible to me. Okay. All right. So there is something that bothers me about this, actually, which is, I'm pretty sure that this code is more general than it needs to be, because what it does is it sits in a loop here repeatedly, and then it repeatedly reads either params or results. And I guess in parse function, do we have a similar... Yeah, similar things happening here, where like inside a function definition, we iterate over all of these kinds of things. And then for every single one, we say like, is it an export? Is it a type? Is it a param? But I'm pretty sure on reflection that that's more general than we need, because actually, if you look at, I mean, what is this? Type. Type, optional ID, func type. So yeah, it says func. And then it's not a mixed bag of param and then result and then param and then result and then result and then result and then param and then result and then param. That's not syntactically valid. It's a sequence of params and then a sequence of results. And I think that this doesn't capture that properly. It does work, but what I would really like to be doing here is say like parameters equals parse parameters, do that first. And then I'd like to be able to say results equals parse results or whatever. Like, that's the code I want to see here, not this kind of, initialize these local variables and then iterate over this, because it's inherently awkward whenever you've got this situation where you've got more than, if you really do need to extract all of the parameters and all of the results out of a big soup of both, then you have to do it like this. You have to sort of start out with 2 empty collections and then go through and then stick them into the right collection as you find them. But we're really not in that situation. So I think in the interest of like refactoring towards that, I want this to be like while can read list starting with param, then like, read parameters. And then while can read list starting with result, read results. And so I think, I mean, if this read list that's around the case there, if I instead transplant that to be inside the case, sorry about the indentation here, I know that's gone a bit gross. Well, why don't I remove the comments for a second while I do some surgery on this. So if this read list here goes away, and then instead we say, this is the thing that reads param, this is the thing that reads result, then essentially I think I can explode this repeatedly do. Well, I mean, you know, now I don't have a helper for doing this while can read list starting with. And I guess I could add that functionality to repeatedly. But for now, I'd rather just tidy this up and say, like, I'll say this is read. Okay, hold on. I'm taking too large a step here. Let's just move this furniture around a little bit. So let's say instead of read here, if this was peak, and then we say read list starting with param, and here we say read list starting with result, does that still work fine? Seems to be okay. So yeah, I'll come back and check that in a minute. But I think this makes it clear what's going on, which is that over and over, we're picking up these lists that either start with param or result. Oh, no, I'm not peaking properly, am I? This needs to be right, because it's not inside read list anymore, so what I said was sort of nonsense. But this is if can read list starting with param, do that. And then this is else if can read list starting with result. So I think that's where I was trying to go, was to say, yeah, we iteratively try to read either a param or a result, and now what I want to do is pull that apart and say, well, let's just keep reading params until we can't anymore, and then let's keep reading results until we can't anymore. And I think that makes it, okay, so that works. I think that makes it more obvious what's going on. Maybe I should commit that. So let's say read param or result list inside conditional in parse type. I'd like to separate these entirely because it's not syntactically valid to mix up the param and result parts of a type. All the params have to come first, followed by all the results. And that's not clear from the current implementation. If I could handle them entirely separately, then they could be extracted into separate methods, which will make parse type easier to understand. I think that encapsulates my motivation here. So now, having done this, I guess this repeatedly do if can parse list is essentially what this while loop is saying. So I think I can just move the guts of that here. And likewise, this thing here can just go inside there. And then that thing can just, oops. That thing can just go away, I think. Let's just see if that works. So I think this, I don't know if I'd saved that. I think this, well, firstly, this more clearly expresses what's going on. And secondly, this creates an obvious opportunity for these two parts to be extracted. I suppose I should commit that. Use two separate loops to parse params and results in parse type. Okay, that looks okay. Now what I'd like to be able to do is just extract these so that this could be like parameters equals parse parameters, I guess. That's going to be a problem for the, well, looking at this now, I realize that because read list returns the final thing, I could actually move this inside the conditional. And if I do that, then these can live inside the conditional as well. Well, it's not conditional, is it? It's inside this block. So if that works, I think it's something like move parameters and results local variables inside read list block. The read list helper returns the value of the block, so we can construct the type instance inside it rather than the local variables to communicate the params and results out of the block for us, not outside of the block for us. Okay, and now I think just trying to think what the right order of operations is here, because definitely the guts of these things like if I pull out these guts and put them into parse parameter, and pull out these guts and put them into parse result, just realizing these don't hold on, let me just think about what needs to happen here. So this says parameters.concat, so I think I have to leave that behind. This has to, because this is about modifying this local variable. So that's the parse parameter thing, and then this says concat parse parameter. Here we had results concat, that needs to be left behind. Actually, this parse result is really not doing anything, is it? Well, that's because we're not actually, all we care about with the results at the moment is how many of them there are, and just the length of this array. Because at the moment we're not actually looking at those values for any reason. They're just the names of types. So we don't have a good representation of that for now. So yeah, I was just pausing here because I realized that, you know, according to that convention I was talking about before, the first thing that should happen here is that we should be reading param. And here we should be reading result. Is that a problem? I don't think so. I think that's okay. I just have to take this out. I think that's all right. Now that this is scoped inside I think we sort of avoided calling that local variable name because there was already one here. But now I don't think there's any reason that this needs to still be called parameter name because this is inherently something to do with that parameter. So I think that's all right. Let's try running it and see what happens. Okay, nothing's obviously broken. Okay. So what is this? This is just extract parse parameter and parse result helpers. I mean, that's made this a bit nicer, but like I said, I think the real payoff here would be to be able to hide this detail entirely and have this just be just deal with all of the detail inside helpers. So here you read func, then you read the parameters, and then this is parse results. And then these two just get pulled out. So that as far as we're concerned, this is what parsing a type means doing. As this thing here, we're reading the name. Again, this is maybe something that, maybe reading a name needs its own little helper, although I'm not sure what to do about the fact that it's sort of optional. Anyway, we read the name and then we read this list that consists of the func opcode, then the parameters, then the results, and then we build this type object, and then we sort of have we have these two methods down here that take care of the details. And yeah, like I said, at the moment, we don't have a nice helper for accumulating the result of this while loop. Like, this is just going to have to be in the same way that repeatedly has just got this. Oh yeah, repeatedly has also got this until, but effectively it's just got this tap at the top. I think I could just do the same thing here. So here we can say accumulate into that array. And then the same thing here. And then I think that makes a parse type, like, well, obviously it makes it easier to read because now all of the annoying detail is hidden down there. Again, I'm extremely conscious of the fact that this isn't very interesting software engineering, but I think what I'm doing here is essentially recovering the structure of the parser I would have written if I'd sat down and looked at the grammar properly. But instead, I'm just sort of finding out where the seams are and trying to recreate them with these sort of recursive parsing methods. So let's just say extract parse parameters and parse results helpers. Okay, and that's made parse type quite nice. I don't immediately know how to make these while loops any nicer. So I think I'm just gonna live with the fact that they're not especially nice. And it's fine because they're sort of hidden down inside those helper methods. So cleaning them up is sort of feels a lower priority, to be honest. Okay, parse parameter. Oh yes, well, I've just extracted those, so. I don't think that's too bad. Oh, there's a lot of stuff in here. State of this. Well, okay, well, I can see several problems with this, but chief among them is that it's suffering from that same malaise of having things in, you know, it's not clear from looking at this. I think if we look at function definitions, we should be able to see that things come in a certain order here. You get the name and then type use, which has got type and then param and result potentially. And there's all sorts of abbreviations here that make this more complicated. But essentially we've got func, ID, optional, param, result, local. Oh, and exports as well. So they do actually, this is the order that they appear in. Export, type, param, result, local. But again, you can't tell that by looking at this. And I think what I would like to do down here is a similar sort of transformation to what I did up here, where this makes it much clearer how parsing a type works, which is that, well, you parse the parameters and then you parse the results. And I think we should, I mean, I sort of forgive myself for not having made it that way from the beginning, because this whole thing was just kind of coalescing together under gravity at the time. But now that I've had a chance to think about it, I think probably this should be, oh, and look, there's even params and results in here. So really, this thing here, if peak in, was that parse parameter? Yeah, if peak in, parameter.new, except parse parameter, yeah, in accordance with the previous constraint. Oh, so this is parameters gets parse parameter, and this is results gets. Oh, no. It's concat. Because parse parameter, because this can return, because there's a loop here. So this can return an array. Yeah. Parameters, parse parameter returns an array. Same here. Parse result, that is. But for either of those to work, we need, this is reading the opcode off, so we need to stop doing that. Yeah, it's the same situation again. Okay, hold on. There's several things that are bad here, but let's just take it one step at a time. So stop reading the opcode, and I think here I'll just reinsert this in all of the other cases to preserve their semantics. You know, they're expecting the opcode to have already been read, so now they are doing it. But these two cases where I've got a helper that's going to consume the opcode, I'll just let that take care of it. So let's see if that works. Now, if that does work, I guess the question is, should this change be part of the change that introduced those helpers? Or should I make a separate commit that says, like, use those helpers in... I mean, at the very least, I'll do it. I'll either make it part of this commit or I'll move it to be after that commit. This is a little bit messy, isn't it? So maybe it's better to keep this as separate. In fact, maybe... let's say... so what I've done there is actually get rid of the... because this is sort of the... this is the first part of that transformation, right? Is to say, allow each of these cases to read the opcode themselves. Make each case read its own opcode in parse function. And then this will say, this is a prerequisite for being able to use the parse parameter and parse result helpers inside this case, because they expect to be able to consume their own opcode. So yeah, I think it's worth separating that change out. And then now I can make a commit that says use parse parameter and parse result helpers in parse function. And then I'll just move those two so that all of the... we extract parse parameter and parse result, and then we sort of use those extracted methods here, and then this extracting these other ones comes later. So I think that's probably the sensible order to do that in. Yeah, I mean, there are several annoyances here, but one of them is that, and I suppose this was one of the ones that I wanted to look at, is that there's, I think, lots of occurrences of this chunk of code. Let's look for that. Start with $. Yeah, so there's at least a few of those. I think this should just be type index equals parse index. Maybe I'll put that here. Oh, this is part of it, isn't it? Sorry. And let's not call it type index. So this is just the generic thing for, I want to read an index, and then either it's a string or it's an integer, and this just takes care of the difference between those two things. So let's look for where else I could do that. Start with $. Read index. Yeah, okay, here we go, look. So this is just index equals parse index. Okay. Oh, this is actually just doing the same thing, but it's doing it in a slightly different way. Okay, well, all the more reason to parse index, I suppose. Is that right? Yeah, I think so. Let's just start the test running to check that nothing's terribly broken. No, okay, here's another one. This is just table index equals parse index. Oh, in fact, look, the assignment is outside here. So this one, yeah, so I'm just thinking about what do we do about this sort of it's optional situation. And I don't think it is right to push that down into parse index. I think it makes more sense for parse index for us to only call it when we know that we're going to be parsing an index, and then the decision about whether that's the right thing to do has got to be done by the caller, right? Looks like that's it. That's certainly the only occurrence of that thing. Surprised there aren't more. Surprised there aren't more, because indexes are all over the place. Like this. Why didn't I find this type index? If can read list starting with type, read list starting with type do. So is this actually a read index and I just haven't done the work to cast it? It looks like it, doesn't it? So that doesn't seem right. I think this should be parse index. I mean, maybe the thing that I was searching for should have been this regular expression, but it's a little bit painful to find those, isn't it? Yeah. How little of this can I get away with searching for? Maybe that much? Let's escape all the backslashes. Okay, so there's one there. So I think this is... It's calling it name rather than index. But again, I think... Yeah, let's just have a look. So what does the syntax say? Tables. Table. Table types. Funkref. I've sort of forgotten how tables work. I think maybe it's this. An element segment can be given in line with a table definition. So that's actually what we've implemented here, is one of these abbreviations. Table, ID, ref type. So actually, I think this is not right. I think. Like here, syntactically, a table has always got to be followed by an ID. An ID is always something that starts with $, so I think that's just a mistake. I think I used the wrong regular expression there. This is inside unfold, which, yeah, works in a totally different way, so I can't really use any of my That's another problem. Can't really reuse any of my existing helpers there. That's... yeah. Can't really use it there because this is making a decision. Okay, so... so I think I found all of the places where we're currently reading indexes. So this is just extract parse index helper. And then, yeah, let me just deal with this. So I think this actually should be... well, there are other places where we're reading IDs, right? Yeah, like this. We just say something that starts with $1. So we can at least be consistent about that. Let me just... I do want to see the tests parse because that's just based on my understanding of the spec rather than reality, but I think that is just a copy and paste mistake. Oh, and also this needs to be... sorry, I need to change this as well, don't I? So let's just let that run. Okay, it's looking at least hopeful. Read an ID, not an index, in parse table. I think this was just a mistake. Tables can only... well, table can only be followed by an ID. Oh! I've broken it. Well, maybe I'm wrong about that then. Funcref equals 1 does not return true. So that's line 274. Let's put this expression dot inspect here just so that we can see what's going on. Table. Oh, well, apparently I'm wrong. Is this just some kind of... well, let's see. Stack.wast. So this is table 1. So what is it that makes this... obviously I'm wrong. Limits. I'm not actually sure what that 1 even means. At some point, presumably, I did know what that 1 means. table 1 funcref. Yeah, as usual, I'm being somewhat stymied by my lack of knowledge about WebAssembly. I mean, I would say that this table doesn't have an ID. That number means something else, and I think that was being papered over by the parser. Let's just spec test core get grep table. So it is sometimes, like, this is what I was expecting, is that it's either followed by an ID or there is no ID, and that is sometimes the case, but clearly it can also be followed by a number. What does that correspond to syntactically? Is it part of the ref type? No, that's what funcref is. So that's the ref type. So it must be this table type. It must be limits. I think it must be this, because that's the only thing that can put a number in that position syntactically. So we must be looking at, this is sort of minimum or minimum and maximum. Okay, so I think I'm gonna say can I use repeatedly? Can I say repeatedly until what I want to do is parse integer. So flush out any integers, and at the moment I'm not going to do anything with them. But these are the limits. So repeatedly until it's similar to this. Similar to this, I'm going to say, I mean, this is obviously a very unpleasant API that I need to think about. But essentially I want to say until, let's just say it's going to be 1 or more digits. So until we see something that isn't an integer. Oh, I mean, maybe integer is too strong a... I mean, technically, no. Technically, it can be... It could be in hex. So we do need to do a bit of parsing there. It actually can't be signed, but I don't have a way of, in the moment, parse integer just... I think for now I'm just going to say it's a decimal number, and then we'll cross that bridge if we come to it. Missing keyword bits. Ugh. Oh, it does say it's 32-bit, so fine. Okay. So okay, that was a silly mistake that I've only just noticed. But at least I've flushed that out now. So there's actually two different changes here, aren't there? Oh, hold on. Well, I've already made that change. Okay, read and discard limits in parse table. And let's explain what we know. The table type but presumably this is optional. Yeah. The table type, if present, begins with 1 or 2 integers representing the, I mean, what is the limit? The limits of the table type. What is that? The minimum and maximum size? Yeah. Okay. Okay. But actually, I want to do that first, which is going to give me a merge conflict, but that is the right resolution. And then that's the right resolution of that. So I'm more confident about this now. This was a mistake. Table can only be followed by an ID. This incorrect regular expression was hiding the fact that we'd we'd overlooked the possibility of table being followed by numeric limits. Now that we're explicitly parsing and discarding these, we can be more strict about about the syntax of the table name. Okay. Whew. All right. Okay. So that was what I extracted parse index, I think. Yeah. Okay. I mean, that was a bit of a production, wasn't it? But we got there in the end. Oh yeah, and I got parse parameter and parse result. I can sort of see this here. Essentially, this is a peer to parse parameter and parse result. And it should just be locals concat parse local. Should I put that after parse parameter and parse result? Yeah, I think I will, even though it's not actually used until down here. I think it sort of belongs with them. So this can actually just be literally local now. This is just return the 1. This is, well, I'm going to change this to look more like that. It's the same thing. In fact, these are very similar. So this is basically identical. It's just parameter .new versus local.new, but otherwise it's exactly the same. But I'm sort of less concerned about that repetition, or at least that's fodder for some future refactoring. But like, I think when the repetition is pushed all the way down to the leaves like this, I'm sort of less worried about it. If it turns out that par's result is also the same, and I've got 3 that are exactly the same here, I might want to generalize this and have a helper that can do all 3. But for now, because there are only 2 cases of it, it feels like it would be sort of premature abstraction at this point. Let's just let that run. So this is just extract parse local helper. I'm actually quite pleased that I caught that problem with the table ID, because that's exactly the sort of thing that could have sat there for ages without me noticing it. But the fact that I was like doing this cleaning up and trying to consolidate all of the things that were doing the same thing kind of actually flagged a problem that I was otherwise not aware of. So that makes it feel a little bit more purposeful than just rearranging the deck chairs on the Titanic, which is otherwise what this kind of refactoring tends to feel like. I'm wondering how much I care about this. I think maybe I'll keep going and then come back to this in a bit, because this whole thing needs to be cleaned up. But I've now got a bit of a fear that there are places further down where I should have been using some of the helpers that I've defined already. So I think I'm going to keep going, and then I'm going to try and come back to parse function and sort of deal with the situation that exists here with respect to these things not being obvious that these things appear in a certain order. So parse memory I'd looked at before. This has already had some love in terms of extracting parse memory data and parse memory sizes. Parse table, I was just looking at this stuff at the beginning. Now I think maybe yeah, this sort of element segment is given in line. If can read list starting with LM else. I mean, that could straightforwardly just be parse elements, right? I'm not sure. The reason I'm hesitating is I'm not sure what to do about this func ref. Like, that's obviously the only kind of reference type we've seen so far, but it could also be extern ref. But I don't know what that means. I don't know what that changes. I'm trying to eyeball this to see what the ref type here actually affects in terms of this abbreviation. I guess it ends up in the table type. Like it's this ref type inside the table type. So maybe I'll just leave that alone for now. But I think I could pull out this thing that parses the elements, right? So at least this bit here. I can just make that def parse table, or maybe just parse elements. I don't think there's any other notion of element. I'm really struggling to think about like how do I want these responsibilities to be divided? Maybe this isn't worth messing with. I think this parse table is a bit underbaked because I haven't really had to deal with tables yet. So I'm actually wondering whether this is... No, I think I'm gonna, because I'm just thinking about parse parameters, for example. Like, the job of this is to consume as many of these as possible and return a list of them. So it feels like maybe this is okay. I'm not 100% sold on it, but I think it does help to tidy things up a bit. You know, either they're there or they're not. And if they're not, then we get an empty list. I'm not as sold on that as some of the other stuff that I've done here, but I think it's probably okay. Basically anything that decomposes these things into smaller pieces, I think is going to make it easier for me to get my head around it in future. So I'm going to do that, even though it doesn't really feel like a big win on this occasion, but I think I can live with it. Okay, parse global looks okay. It's basically just calling, well, it does this thing, but at the moment that's just discarding the type information, so I'll just leave that alone. Unfold is a whole separate nightmare that I need to think about. Parse instructions is quite nice. That just repeatedly calls parse folded instruction or parse instruction and then flattens the result. Read list is an existing helper. Parse instruction looks good. Maybe these helpers should all be sort of, certainly these read helpers, maybe these should be, they should all live together at the bottom. I'm not sure why that is in the middle here. So why is that? All right, well, whatever. I obviously haven't thought about what order these method definitions should be in. I haven't suddenly looked at it. I'll leave that for now. Parse instruction looks good. I think this is like the platonic ideal of what I want to see inside one of these methods, so that's good. Parse folded instructions isn't really doing anything. Parse numeric instruction. This is necessarily a bit long and messy, but I'm not sure there's much benefit in breaking out these pieces. Like, obviously I could break out this could be like, well, we've already read the opcode. This would otherwise be like parse const or something. I mean, this could turn into a peak. This could be case peak. Oh well, yeah, we break it up using the regular expression. I think I'm going to leave that alone for now. It's quite large, but that's like doing a single job. Parse structured instruction. Right, so this is where it's the results again. So hold on. This is a slightly different bit of code than if you look in parse results, it looks for multiple list starting result, but this one only reads one. I wonder if that's right. It probably isn't. I think probably if we look at this and look at a structured instruction like block, block, label, block type, so where does the result thing come in? So either a type here or a type use. Type use lets you say param, result. So actually we're not even parsing the param part of this. But we certainly should. I think basically what I'm saying, the right thing to do here is parse results. And the fact that we weren't doing that yet, I think is probably fine. But that's the more correct. I think that's the more correct thing to do. So that's another one for me to shift backwards a bit, I think, when we introduced parse results. Yeah. What did I say? Yeah. Use parse results helper in parse structured instruction. Previously, we were only trying to read a single result, but that's not right. A type use can have multiple result lists. We should also be trying to read multiple param lists, but we haven't needed to do that yet. Okay. So there was something in here about this sort of trailing label stuff, and that kind of comes to a head in here, right? Where there's up here, we read an opcode followed by a label. And then here we read an else followed by a label. And then here we read an end followed by a label. So I think what I'd like to be able to do is have some kind of read labeled helper that I can do here that will give me, in this case, the opcode and the label, because that's what I need to know. But then, well, I guess that would, let's assume that those things go together like that. But then here, when I read labeled, I want to specify that I'm reading a labeled else, and I actually want to say, and the label is blah. And then when I come down here, I want this to be read labeled end. So some combination of these three things needs to go into that that read labeled helper. So I guess this is going to be like atom can be nil and label can be nil. I mean, I'm not sure it's necessarily right to have two different to sort of have a single implementation of this, because really, in the first case, we need to know what the atom and label are, and in the other cases, we're saying what they are, and then there are these sort of essentially assertions about what the label is and what the atom is. But I think I can just do those independently. Like, this is what it looks like. First, we have to read the opcode. So let's just say if atom is nil, then we read into atom, else we read into pinned atom. So it's going to raise an exception if we didn't read the thing that we thought we were going to read. So hold on. If label's nil, then we do this, right? So bearing in mind that the label is itself optional, yeah, that works both ways. If either we haven't been provided this label keyword, or if the label that got read was, or if there was no label, then it's going to be nil. I guess the else clause is just what we had before. So if you haven't provided a label, then we can try optionally to read a label from the input. If a label has been provided, but the label is always optional. So, okay, this conditional needs to go around the outside. This whole thing needs to be optional. Because even if you've said the label is foo, it's actually okay for it to not be there. So I think this is right. We just try to read it, and then we just need to return the atom and the label. So now we're reading a labeled opcode up there. We're reading a labeled else here. We're reading a labeled end there. Again, it's not going to change the world, but it does reduce that. It both reduces and names that duplication inside parse structured instruction. Oh, except it doesn't. Read labeled wrong number of arguments given 1 expecting 0. 510. Oh, I intended for this to be a positional argument. Sorry. Okay. So that hasn't fundamentally broken anything, so that's okay. In fact, now that this has been cleaned up, because inside if here, we've got to assign the consequent, we've got to deal with the else if it's present, and then we've got to deal with the alternative. But actually, I think the only thing that needs to be conditional here is reading the else. Like, I think it's okay for this to be outside of the conditional. Because if there was no else, then parse instructions is just going to read, or in fact, even if there was an else, it could read an empty list of instructions. So I don't think there's any need for us to guard this. I think this could just be a postfix. conditional like that says like, you know, we try to read an else if there's one there, including the label that we got associated with the opcode. And then whatever's left, even if it's nothing, is the alternative. And maybe there wasn't even an else, but that doesn't change, I think. Yeah, because we were reading until else here, so I think that will make sense. I think that's a little bit clearer. So the else is optional, but we always need an alternative. Yeah, and I don't think we ever really want alternative to have the ability to be nil, which at the moment it kind of does. I think it's better for alternative to be an empty list of instructions than for it to be nil. Yeah, I think that makes more sense. So let's just say unconditionally parse alternative in parse structured instruction. If it's empty, we'll just get, which is what we want. So if it's empty, or there's no else at all, yeah. Okay, I think that's good. All right. I think that I'll pull out this part. And I sort of want to pull out the alternative as well, even though it just calls parse instructions. Because I like the idea of this just being parse consequent, possibly read the else, which is, I think, almost exactly what this line is already saying, so I don't know that needs to be extracted. And then this needs to be parse alternative, even though that is just reading instructions. So I'm going to do that really just for the sake of consistency, I guess. You know, I want everything inside these methods as far as possible to sort of be at a comparable level of abstraction and to be easy to, I want these lines of code to be easy to read, even if actually it's not adding anything except a name. So let's see. Let's check I haven't broken anything there. Extract parse alternative helper. This doesn't do anything beyond call parse instructions, but it's here for symmetry with parse consequent. I think this makes the parse structured instruction method easier to read. Well, this makes the else, the if clause, the if case of the parse structured instruction method easier to read. Okay. Yes, that is what it affects. Okay. So now what do I want to get a bee in my bonnet about? I think I've said before that it feels a little bit unnecessary to be repeating these regular expressions all the time. Like even just looking at this, it's like, why is this? Why is that not just, well, ID regex, I suppose. Why don't I see if I can find all of the occurrences of this? And I expect I should probably define this either right at the top or where it's first used. Okay, and parse type. So let's move this up there. Yeah, it's tempting to extract this idea of reading an ID, even if it is just... Oh, look, we use it inside unfold. Okay. All right, well, look, I'm going to try not to get distracted. Let's just say extract ID regexp. And then do I have any other? Yeah, there's the one for indexes, right? I had that. I was searching for that somewhere. Yes. Okay, well, again, I'm not sure whether there should be... I mean, so many of them are inside unfold, which I sort of want to go away anyway. Yeah, I mean, there aren't enough of those that it really bothers me. So this was index. And yeah, that's defined before parse index, which is the first place that uses it, apparently. Let's just run the test to make sure I haven't done anything silly. Okay, that's looking hopeful. Okay, well I've kind of lost my place now because that's caused me to jump around all over the place. Oh, look, this here, read unless self s expression empty. This can just be finished. Use finished in read list instead of self s expression empty. That's a little bit more expressive. It sort of indicates that, well, it indicates that you're supposed to be finished by the time you're done with that read list block. Okay, this isn't super exciting, is it? But, well, let's see. Is there anything else objectionable? So this is like into all of the existing parser methods to do with normal instructions and numeric instructions and things. No, this is all just helpers down here. So I wanted to go back to parse function. This is sort of what I was shying away from before. And I think this is sort of where I want there to be some attention, because I think when I get into doing things like keeping the names of locals in an identifier context, then that's going to affect parse function, I think. Yeah. Because the parameters and the locals become identifiers here in the identifier context. So I think what I'd like to do here is, rather than have this loop that's pulling stuff that's just pulling unknown lists out and then deciding what they are. I think I want to... Well, so they have different sort of multiplicities, don't they? Like, for whatever reason, we're expecting that there's only one exported name and only one type index here. So I think rather than... Let's try this. If I sort of get rid of the exported name part here, and I just say if can read list starting with export, then exported name equals well, hold on, this can be at the top level, can't it? So this is read list starting with export do, and then this is just read, I think. So it's like, if it's possible, if there is one of these lists starting with export, then read it, and then the thing that's inside it after the export atom is going to be the exported name. And then we don't need this anymore. So I think, yeah, what I should have said this. What I was thinking I could do is just peel each of these out. What did I... Oh, yeah, right. So I removed the local variable from here, and I removed the case from here, but I think I also need to remove this from here. So it's like we get one fewer local because it just gets assigned, oh, I guess the value of that corresponded to that local. It's now short enough to fit on one line. So the local variable moves up there, and then we're not looking at it in this... inside this repeatedly anymore. It's just a little bit... It's a little bit indenty. That's the only thing I don't like about it. What if this was like this? Is that okay? Exported name equals read list starting with export read. I think that's a little bit less difficult to understand. So what did I say before when I did this? Use two separate loops to parse params and results, yeah. So let's say something like use separate conditional to parse exported name. Well, maybe just export in parse function. Something like that. This and the the information that can appear between func and the function body can only appear, well, the information that can that lives between func and the function body can only appear in a certain order. So we don't need to switch every time. So we don't need to support an unordered So we don't need to support reading it in any order. 170 subscribers. Wow. Thanks, Tyrek. Well, I don't know why, because if anything, this is getting I feel like if I don't start working on the parser soon, then nobody is ever going to want to watch any more of these. So I'm gonna need to advertise on Mastodon and Twitter when I've actually started working on something a bit more interesting. By the way, 3 hours remain ish. 3 hours 9 minutes and 30 seconds remain before the 100-hour mark. So start warming yourself up to celebrate 100 hours of tedium. Okay. The information that lives between func and the function body can only appear in any order. I'm going to move the pieces out of the loop one at a time, starting with export. Maybe I should link to the functions. So, yes, okay. So I don't see why I can't just keep this up and do the same thing with the type, which is sort of the same, right? So we get rid of that. We get rid of that. We get rid of that. And we get rid of that. And then this just becomes if can read list starting with type index equals read list starting with type. But in this case, I guess it's parse index rather than read, because that's what we were doing down here. Use separate conditional to parse type in parse function. Okay. All right. Wow, the 170 subscribers has given me a real second wind here, given me the motivation to get through this so that I can start doing something more interesting again. And, you know, one day I'm going to break that 200 subscriber mark and I'll be able to, well, this is the point where I would ordinarily say I'll be able to quit my job, but I have, of course, already done that. So I'm not sure what I will be able to quit as a result of my successful YouTube career. I'm trying to think about that. Right, so this is interesting, isn't it? Because what I need to do here is, I was just pausing and thinking, what I need to do is repeatedly call parse parameter for as long as it's possible to read a param block and accumulate all of the results of doing so into an array. But I think that's what parse parameters does. So I've already got a method that does that. While can read list starting with param, read list do parameters.concat parse parameter. So I can just say parameters equals parse parameters, which is way nicer. So we get rid of param here, get rid of param there. I mean, this is, I already feel significantly better about this. So this is use separate loop. Well, use parse parameters. Use separate parse parameters call to parse params in parse function. Yes. Okay. Still looking good. So we're nearly there. So this is results equals parse results, presumably. And do we have a parse locals? If not, then we should. So this will be use separate parse results, call to parse results, assuming these tests pass, which they look like they're going to, even though they're very slow. Okay, there we go. Right, so now, yeah, I think, although I didn't have any motivation to define it before, I think I probably should. I should just do it. I should just say locals equals parse locals, and then this goes away. I mean, this whole thing goes away. Let me just remember what that needs. But really, that whole thing now goes away. I mean, this is just that, isn't it? Which I think is a great deal better. Do we have a parse type? Oh yeah, that's specifically, this is like a type def, isn't it? So that's not quite the same. Okay, well, I'm not going to get too distracted by that. So let's have parse locals here. So I think, again, this is going to be exactly the same. So now I do have parse parameters, parse results, and parse locals are all basically the same. Parse parameter, parse result, and parse local are all basically the same, except result is sort of the runt of the litter because we haven't made a result AST node for it yet because we haven't really needed one. I think I'm gonna leave that for now and then just write down something here to say reduce duplication between parse param, parse result, parse local, and what is parse parameter? Parse parameters, parse results, parse locals. How do I make that not be a weird hashtag? Because that is starting to get a bit silly now. Maybe there is maybe there's some helper. Well, I mean, obviously there is. It would just be all of that. This wrapping here, and I suppose the concat. Yeah, I just can't think of what to call that. Oh, it's parse function we were looking at. No, it wasn't. Yes, it was. Okay. Okay, anyway, does that work? Before I start thinking about reducing duplication. I mean, I'm not so worried about these. Like I said, these things that are at the leaves, I don't really mind so much if there's a bit of duplication there, because they're just doing a simple job anyway, and it's easy enough to clean up later. It's these ones like this one, parse function, that if it's a mess, it makes it harder to do things introduce an identifier context, which is exactly what I'm trying to work my way up to. I wonder if there's a way to make this a bit less, syntactically a bit less extreme. This is locals equals parse locals, but then I think what I'm going to do is leave behind this silly... I'm going to leave this silly mess behind. Despite knowing that it's silly. Just because this is the sort of natural continuation of that. Of that pattern. Let's do this. We'll use this next in parse function. Okay, and then this becomes use separate parse locals call to parse locals. Okay, and then no, this is clean up unnecessary code in parse function. What's a better word than unnecessary? I can't think of a better word. Okay, so now I think it's far clearer looking at this what happens, which is that in order we read the exported name, the type index, the parameters, the results, the locals, and the body. And these four can all be empty, actually, I think. Each of them can be empty. I mean, this is a massive improvement from what was there before, so I'm perfectly happy to just leave it at that. Vestigial. That's a better name for it. It's not so much unnecessary as left behind and no longer necessary. Okay, good. I'm glad I thought of a better word. I think I am going to pull these out. I think this is going to say exported name equals parse export. Whether that's the right name for it, I don't know. Superfluous. That would have been a good word. Thank you, Chris. I think that's, unfortunately, it's come too late. I've moved on. You need to fast forward the stream, mate. Superfluous. That is a good word. No, I'm gonna stick with my choice. If that had come through 10 seconds sooner, you might have won that one next time. How do I feel about this potentially returning nil? I think that's okay. I think I have to be okay with this. If I'm okay with writing a helper that says while can read list and it returns an empty array, I think I have to be okay with this as well. But the main reason I'm okay with it is because it makes parse function easier to read. So this would be type index equals parse. What am I going to call this? What does the... Yeah, it's really the type use that I'm parsing here. So let's call it parse type use. I suspect before too long, I'm going to need to return more from these or support more syntax inside the type use because that's all these various, well, I suppose actually the type use includes these params and results. Like that's how they are getting into the function definition. At this level, we parse the... Hi Marco, welcome. At this level, we parse the function ID, and then we parse the type use, and then there are the locals. So actually, if I'm going to extract this at all, I think the parameters and results should probably come with it. And then I suppose I'll return them in some kind of... Well, what I've done above is just put them in an array, but there's a temptation to put them in a hash. I think for now, let's try this. Parse type use goes into type index, parameters, results. I'm not 100% sold on that, but I think I need to make a decision more generally about how do I do... If I've got helpers that return multiple values, I mean, maybe what it should be returning is some kind of AST node, which in itself would be a solution to this problem. Yeah, what does the... Again, I don't have to do what the spec says, but what does the spec think a function definition looks like? Type, locals, body. The type of a function declares its signature by reference to a type defined in the module. The parameters, indices, locals, body. So yeah, I'm not quite ready to have this because I don't have an identifier context. I'm not ready to get rid of all this name information yet. And likewise, these parameters and results should actually go away because what this is implying, or this is alluding to the fact that by the time we've parsed the AST, we shouldn't be storing inline information about the type inside the function. There should just be a type index here. And if there's not been a type def in the module to talk about this type, you know, these 3 integer parameters and you get these 2 float results, if there is no such type in the module, then we need to synthesize that type in that. You have to append it to the list of type definitions in the module, and then the type index should point to it. So, sorry, this is boring, but there's something more complicated going on here that I'm not quite ready to tackle yet. I think once I've got the identifier context plugged in, or perhaps in the process of plugging in the identifier context, I'm going to have to deal with this. Like, yeah, I'm not... I think this is going to come out in the wash, but like not now is the point. that I'm not gonna do the wash right this moment. So I guess I can just do a little ultimately how do I get back to what I was looking at there? Functions. Ultimately, a function should be represented in the abstract syntax by only a type ID, a type index, a vector of locals, and a body. E.g., by generating a new type def if one for the function's type, if a matching, if a suitable one doesn't already exist, but we're not ready. But we won't be ready to tackle that until we have an identifier context. Okay. Whew. Okay, fine. This really does seem... Let me just see how easy it would be to reduce this duplication, because it's starting to seem a little bit silly now that I look at it. Read lists, starting with... Because we don't need... Because the pattern here is always the same, right? We don't need any other predicate to make this work, because you can always call this, and if there are no lists starting with whatever, then it'll just return the empty list. So this is results, while can't read list starting with read list do results.concat, and then this should be yield, because this is the part that we need to vary. And then this whole thing just becomes read lists starting with param, parse parameter. This becomes read list starting with result, and this becomes parse result. And this becomes read list starting with local, parse local. So there is still a bit of repetition there, but hopefully the good kind. Like I'm not doing some meta programming. Like I could just, well, it's not even the same string, is it? Because I haven't named these method calls necessarily after the atom that appears here. So I think having a little bit of flex there and not just doing it magically is probably... Explicitness is good, right? Okay. Extract read lists helper. Yeah, I think that's okay. I think it makes it easier to it makes it more obvious that these three things have got exactly the same structure, right? There's less reading required to understand that. Okay. Well, I feel like I've probably squeezed most of the blood out of that stone in terms of just... I know it's been... Oh, my timer died. That's unfortunate. Oh, no, it didn't. Okay. It's been 2.5 hours. Oh, my timer did die. Oh, no. Well, I'm not going to know when the... I'm not going to know when the 100-hour mark is now. Oh, I can probably work it out, can't I? Yes, I think I've probably squeezed all of the blood out of that stone is what I was saying. So what I'm going to do is think about... The thing I've been avoiding thinking about is this. Now, the thought occurs that the only place this gets called, I think, is in par's unfolded instruction. Or par's folded instruction, sorry. So here we say read list from unfold of read. So we read... That read is going to give you the whole folded instruction. And then unfold is going to flatten it out into a long sequence of instructions, and then we can parse them, or a long sequence of atoms that represent instructions, and then we can chew through them. But like, the reason why unfold needs to know about instruction arity is, well, see, now it seems a little bit unnecessary, because par's instruction itself, or par's instructions, is all about just chewing off the right amount of stuff. Like if you call par's instruction, it will look at the first atom in the list and it will consume the right number of whatever the static arity of that instruction is. It will consume the right number of arguments. So this thing here that's saying like, oh, if it's any of these that we know take a single argument, then effectively consume that argument and then stick the rest of it in front. And similarly for this, something that takes an optional offset, like I've already got all of that logic down here. If we call par's numeric instruction, we already know about reading the optional offset argument and defaulting it to 0 and all that stuff. So I think I'm at the point now where we don't need a separate unfolding phase. I think that instead of calling unfold here, how's this going to work? Okay. Well, I think the way that the general case is going to look, basically we can do unfolding here and we can use par's instruction to do it. So instead of calling unfold, I can just do read list. I think... Okay. Yeah, okay, this is starting to become a little bit clearer to me now. If we ignore... Because all of these structured instructions are quite inconvenient. So if we ignore all of those and just think about everything else, because everything else, the only complication in any of these cases is how many arguments does the thing have, right? So all of these ones are, one argument. Well, these are like exactly one argument. These ones are optional offset argument. Let's not think about structured instructions for a second. This one is like variable number of arguments. Oh, these are all immediate, by the way. Optional offset immediate argument. Variable number of immediate arguments. And what's the deal here? Must be indexes. Yeah, so like syntactically, however many indexes you can read. So after you've read BR table, then, well, this is one or more. At least one. Well, one or more. But again, when we parse BR table, we have the wherewithal to do that. Like, we've already got the code here that is going to consume repeatedly until you've got something that's not an index, parse index. So we're already doing the work down there. So that's one or more immediate arguments. This is something complicated. Optional index type param result immediate arguments. So that does have several optional and like a variable number of them as well. And this one has what, optional result argument. It's basically the type there. And then this is no immediate arguments. So the point I'm trying to make here is that just disregarding the structured instructions for now, in all of these cases, what we're actually doing is just sort of rest here is what you get after you consume the instruction. And so parse instruction already knows how many immediate arguments each of these things have, and sometimes it's a static quantity, as in, you know, i32.const. In other cases it's optional, as in i32.load, and in other cases it's more complicated than that, and you have to write some code to say, like, well, keep slurping them up as long as they look like indexes, or some of them are optional, or whatever. And then we've got this fall through case that says, oh, if it's anything else, I mean, this is just because I've been lazy. I could have written a huge long pattern match here that lists all of the other instructions that don't take immediate arguments. But this is all covered by parse instruction. So all of these cases, apart from the structured instruction one, I think we can just do something like parse instruction. Actually, what we can do, I was going to say we could parse the first instruction and then... No, but what we can do is parse all of them. So, okay, this is a folded instruction. Let's look at the definition of folded instructions for a sec, because I'm not explaining this very well. So basically, yeah, ignoring these are the special cases, right? Block, loop, and if. I can't select mathjax for some reason. But I was trying to select block, loop, and if there. So ignoring those, let's think about this first case, because this is what everything else falls into that's not block, loop, or if. Everything else, what we've got is a plain instruction followed by 0 or more folded instructions. So we know that the first thing here, plain instruction, it's not clear to me whether this is saying it has to be a plain instruction. I mean, I suppose it must be. Anyway, it's not particularly important, because what I was going to say was, if we just if we just parse all of the instructions, and bearing in mind that parse instructions knows how to deal with folded instructions, which I don't think can legitimately appear here. I think this first thing, the reason that says plain instruction is because it has to be one of these non-structured instructions. I think it has to be one of these sort of ordinary ones. I think if we parse all of them and say, let's pull out the first one and the rest of them, then I think effectively we can implement this by saying, okay, let's parse all the instructions. That is gonna take account of how many immediate arguments each of them has. It's gonna chop up each, that big flat list of instructions is gonna be chopped up into, it's gonna be portioned out into opcodes, immediate arguments, opcode, immediate argument, opcode, immediate argument, and so on. And then to achieve this effect, we just need to swap them around. We need to say, well, if the first thing is some, expects there to be some stuff on the stack, then first we have to do all of the other stuff, and then we do this. So I think that is the essence of unfolding. And I think all of the knowledge about the staticarity of each of those opcodes that currently is being replicated in unfold is actually expressed right here. So I think this is what I was looking for. I think this... I haven't thought about the structured instructions, but I think for everything else, I think this gives us what we want. I wonder if I can move over... I wonder if I can do this sort of incrementally. What would that look like? Like if I pulled all of this out so that it was only structured instructions that was left, because that's, this feels like a bit of a... This feels like a bit of a tightrope walk at the moment. So if I leave these in here, unfold. So what would the condition be here? You have to give it an S expression. Right, so I think this is good actually, because it's not recursive. So it doesn't matter. It's not gonna, yeah, that's what I was getting hung up on, is because this used to call unfold recursively and I was worried. But I think now, if we just call this on an S expression that does begin with block or loop or if, it's going to leave the rest of the S expression alone, but it's going to sort of deal with unfolding the block or the loop or the if, which is what we want. So I still need to get rid of this portion of it, but I'm just thinking about... just think this through. So if I read into folded, so it's sort of, I need to know if it starts with block, loop, or if. Oh, I suppose at this point I know that I'm inside a list. Okay, hold on. Sorry, I'm having trouble thinking about... I'm having trouble thinking about how to make this decision and what should happen as a result, but I think it's... And then how do I get this? Oh, I guess this is just... Okay, yeah, all right. This is what I wanted, is just to sort of make... Only do the unfold if... well, let's just say if folded in a block or loop or if splat. I think that's right. Okay, well, this is going to test my hypothesis. Okay, it hasn't instantly broken. That's a great sign. Okay, well, this is fantastic. Because I just deleted a ton of code. And now I've just got to work out... Oh. Okay, it doesn't work. All right, what's gone wrong here? Local set. All right. So no implicit conversion of array into string. Since I parse normal instruction. Line 522, line 618. Okay. So I guess this is the problem. Indexes equals repeatedly until parse index. So what's happening here? No implicit conversion of array into string. So, right. So the reason this has started happening is because it used to be, before I deleted this, BR table was... Right, there was sort of an optional pattern match here that says, while the rest of the S expression has got a first element that matches this regular expression, then read another index. And that worked fine regardless of what this next thing was. So there was no requirement that it be a string. It could have been anything, although I guess the only other thing it could have been is an array. But if it was an array, then this in would just fail because the pattern match would fail. But now that that code's gone and we're using this code instead, now this is doing something slightly different. This is saying, this is doing a Boolean test here that is repeatedly calling the match method on a regular expression to say, like, is the next thing in the S expression, does it match the index regexp? And I think that this is blowing up and saying, well, you've called it with an array, which I don't think is necessarily wrong. Let's just have a look. Local set. Why can't I type? BR table. Right. So that's what we would expect. We'd say, like, well, look, there's a number and then something after it isn't a number and it's actually an array. But now that a different code path, this... this code path here would never have seen the array because the whole expression would have been unfolded by the time it got into whatever this is, par's normal instruction. So the unfolding would have already happened previously, but now it actually needs to stop chewing off arguments if it hits an array, because this won't have been unfolded yet. It will be when we call par's instruction on this, but that won't have happened at the point where this is happening. So I don't think this is a fatal flaw. I think I just need to say until can read list or it's an atom that doesn't match. So I think I just need to guard this and not try to do the regular expression match if the next thing we would read would be a list. I think. Yes. Okay, well, there'll probably be something else broken, but while I'm waiting for that, I think this was legitimately a bug. Like, it shouldn't have been like that. So let's just do that bug fix. Stop reading BR table arguments if we hit a list. At the moment, this never happens because the instruction has already been unfolded by the time we call par's normal instruction. Well, let's say because... Is that right? Yeah, I think that's right. But I'm trying to integrate unfolding, parsing, so we need to be able to stop if we hit a folded instruction. I think that's right. I'm not 100% sure that I know what I'm talking about there, but that feels vaguely right. Okay, great. Those tests have all passed, so I can actually commit this. So this is... Oh, yeah, that's lovely. Why don't I sort of want to change this. Can I use can read list for this? If block loop if any can read list starting with 1. Well, because I want to get rid of that really, and I'd like to leave this. Then I can get rid of this. So that sort of left, like, the reason why I wanted to do that was to kind of leave this code alone. So to show that we're just sort of, we're preserving the old code path for these specific cases, but this is sort of a new default, I guess. That's why I was messing around like that. I'll let it run one more time, but I think this is right. Oh yeah, I just realized what this is talking. The reason this says plain instruction here is because, like, this is everything except block, loop, and if. So yeah, you can't. If the first thing here was a block, loop, or if, then this is not the right clause of the abbreviation. You have to use one of these other ones. So yeah, you're guaranteed that the first thing that appears here isn't going to be one of these things. So yeah, that makes sense. I'm avoiding the problem of what to write in this commit message because I'm not sure I know what to write. Well, yeah, I was thinking about plain instructions. Let's say use parse instructions to unfold all plain instructions. The parser already knows how to consume the correct number of immediate arguments for each opcode. So we don't need to re-implement this as part of unfold. We can just let parse instructions divide everything up correctly, and then divide the entire input into instructions and then reorder them according to the first. So it's going to be according to the first abbreviation in the definition of unfolding. Block, loop, and if have irregular abbreviations, so we'll have to implement those separately in the next commit, I assume. I'll come back and change that if that turns out to not be true. Did I have... No, never mind. I thought maybe I would want to... This parse results helper, maybe I should have moved that commit earlier, but I think it's fine where it is actually. Okay. I mean, that already feels like a massive win. Like the fact that I was able to delete all of that gibberish. So now, I suppose the challenge is I just have to do the rest of it in line. Like I don't want to call out to that function. I mean, that unfold function is from a different world. Like it operates on, it doesn't read its input one atom or one list at a time. It matches the whole input, and that's sort of a bit retro. We don't do things that way anymore in this parser. So okay, I'm just going to put all this in one place. So this is what I previously said. So if it's a folded instruction, okay, if I'm going to do it all in line, then this whole thing can just be inside a read list, right? Because we know for sure that we're going into a list, and we're not going to be calling unfold anymore here. So just forget it. Now I'm not asking if I can read list. I'm asking, well, this is the first item of the list now. So this can just be a case peek, and this can be in block loop if well, obviously this is where the this is where the code above needs to go, but then I think the else clause stays the same. So okay, so I just have to, let me get rid of all of the unnecessary junk here. Okay. So I'm going to stick this in here. So this is assuming that this goes into the opcode. So if I'm just going to port this code over, it says block loop or if goes into the opcode. So I could just match that up here. Oh, and then this is a label. Okay, so those two lines of code just become read labeled, because that's a helper I've already defined. So that's opcode label. So that's that done. Rest in result type rest. So hold on. I mean, essentially what we're doing is a different version of parse structured instruction, but I think these first two bits are the same. You know, the syntax doesn't, so it changes from block label block type instructions, block label block type instructions end. So yeah, this parse results is really standing in for block type there, isn't it? And yeah. Yeah, in these two cases, well, okay, look, for this kind of folded version, we need to do the read list. Sorry, I realize this is quite chaotic. I'm just trying to think about what's needed here. This one needs to limit how much it's reading because it wants to stop at end, but we don't have that problem anymore. So we can just keep reading what we're currently seeing. So if it's a block, then we need to parse the instructions. And then what's the return type of this? Parse folded instruction returns an array of instructions. So yeah, in general, there's multiple instructions here, but in this case, it's just the one. It's just a block instruction, and then it's got a body that consists of other instructions, but that needs to be an array. Similarly for this, it needs to be an array. This is the one I'm a bit afraid of. Okay, so we've dealt with block and loop here. I didn't even look at that code. So this is this is the thing that I find frightening. So in the what am I doing? Okay, I'm aligning, that's what I'm doing. And let's I'm just procrastinating so I don't have to think about this. Right. So previously we could say parse consequent, which is designed, again, this is reading up until and else, and that's not how this works. This is a different shape. So here we have to, and I guess this is what this is doing. Oh yeah, this was using a find pattern to read everything up until a list that starts with then. So I think what I have to do, I think it's going to have to be another one of these jobs. I think I'm going to have to say start with an empty consequent, and then until can read list starting with then, we're going to need to concatenate now. What is this? Parse instruction. What do I do up until I find then? Oh, look, it says folded instruction here. I mean, this was just making a splat until it found a then. But this would suggest that this has to be 0 or more folded instructions specifically. So here I should concat parse folded instruction according to that grammar. So we're going to be calling this recursively, but that's fine. So we keep accumulating those. Now we've got to read. So this is not optional. There has to be a then, and then this else bit is optional. So we have to treat these a little bit differently. So here, yeah, whatever is inside that list. So we have to say, oh, hold on. I've just realized this isn't the consequent at all. I was getting confused between these two things because, of course, here, this is not the consequent. This is the condition. So that whole thing was misguided. Okay, so the condition, after we've read the label and the, well, we're not even trying to read the block type. We're just trying to read results. Then we read 0 or more folded instructions until we get to a list starting with then. And then we do read list starting with then. Do. And then inside this, I guess these are just generic instructions, right? So these aren't folded. We can just say parse instructions, and then this whole thing becomes consequent. Can I, is that too long to do all on one line? It's a little bit, isn't it? Okay. Let's do that. Okay, so that's better. So we've dealt with the consequent, and then there's this optional alternative. So what's that going to look like? Alternative equals. Okay, so if we can read lists starting with else, then do something else. That should be an empty list of instructions, I think. What do we do in this case? I guess this is just parse instructions again, right? Read list starting with else do parse instructions. So that's kind of the same as consequent, but because it's optional, we've got this conditional around the outside. That makes sense. So that's read all of the bits, I think. We've read the label, the block type, the condition, the consequent, and the alternative. Not just read, but parsed. So now each of these is an array of instructions. And now we need to unfold it. And I think what that looks like is first we have to put all of the condition. So however many instructions were involved in the condition, they have to go first. And then the rest of it, I mean, I should have said explicitly that like the operation we're doing here is not just this, because this is just an operation on concrete syntax. These abbreviations never leave the world of S expressions. But what I'm doing here is turning this into building this into the parser, right? So it's not expanding an abbreviation, it's actually parsing this syntax. And the first one, I mean, I think it was trying to make it an operation on the S expression that was causing the doubling up of the logic, right? Because there is nothing that operates in the world of S expressions that knows how many immediate instructions each opcode has. The thing that knows that is the parser that turns S expressions into AST nodes. And so I'm sort of leveraging that to refigure this as not just an operation on S expressions, but an operation from S expressions to instruction sequences, in which case condition is already a sequence of instructions because it came from concatenating parse folded, whatever the result of parse folded instruction was, because each of those is an instruction sequence, so we build them up into a big array. Could I have used repeatedly here? Maybe. I'm going to think about that in a second, because repeatedly takes a proc as until, right? Yeah. I think I can do that. Anyway, I'm getting distracted. So here, rather than putting together an S expression to represent this, I need to put together an instruction to represent it. So it's going to be if.new. What does if have? Well, actually, I can just copy it from here, can't I? I just realized I've got this. So label, results, consequent, alternative. Yeah, those have all been populated by now. Gosh, well, let's see what happens. Wow. Seems like that works. No one is more surprised about that than me. So yeah, let's just briefly, can this be repeatedly until can read list starting with then? Does that work? I mean, I'm actually not sure that that's better. Oh, but it is better because this accumulates its. So that's the reason. That's the reason for using it. Am I going to need to flatten that? I think I am. I think I'm going to need to flatten it. Yeah, because otherwise it's just it's accumulating nested arrays, and that's not, yeah. Okay, let me try just putting flatten 1 on the end of that and see what happens. Or where was that failure? Float expres. Oh no. 356. I don't understand what it's complaining about. Wrong number of arguments. Given 1, expected 0. Who's been given 1, expected 0? I don't understand. I'm sure I'm doing something silly here. I mean, you can definitely call repeatedly that way. I'm sorry, I don't understand the problem. Oh, is it because this block needs to take a... Oh, yeah, it's the block. Okay. I mean, actually, it was a little bit naughty of me to... The way that I've used this here is a bit... I should really not be relying on the fact that peak works from inside this block. Okay, well, it's not worth that. I don't think it's worth the hassle. I thought I was being clever there, but I wasn't. I was making life more difficult for myself. I mean, obviously, I'm obviously missing some kind of helper there. But the main point is that, well, is that I've got rid of the unfold method, which is fantastic. Let's add this first. So what's the... What did I say? I mean, I guess essentially I'm doing the same thing. Use parse instructions to unfold all structured instructions. Block, loop, and if have a different format to plain instructions, but we can just handle them separately inside parse folded instruction. And then we don't need unfold at all anymore. And so now this just becomes remove unused unfold. Whew. Great. Okay, I'm glad to be shot of that. That is a relief. Now, in accordance with tradition, I wonder if maybe this thing here could be extracted. So effectively, parse folded instruction becomes either, I guess this is parse folded structured instruction. If nothing else, that reduces the indentation level of that code. And I guess this is parse folded plain instruction. Does that work? Seems to have worked. And then this is parse folded plain instruction. Those are the two things, aren't they? Structured and plain, yeah. Good. All right. I feel a lot better about unfolding now because it doesn't exist anymore. Okay, that's looking good. Great. What's this for? Like, we used to call this from the interpreter when we didn't have the ability to parse all of the scripts, but I bet no one else is calling this anymore. Yeah, that became dead. Yeah, we stopped using it at this point. Yeah, there was this sort of incorrect usage of it internally within the AST parser, but I assume it was when... Oh yeah, when we did this change to do destructive consumption of things, and yeah, when we stopped calling destructively consume. Yeah, okay, all right. So this is basically unused now. I will just verify that, but I think if we're not needing it, then we won't have it. Remove unused parse expression. We used to call this from the interpreter and from inside the AST parser, but now nobody uses it anymore. Great. Okay, well, I think that I'm now... How long's that been? 3.5 hours? I think I have procrastinated all that I can. Well, I mean, let's be more positive. I think this is in much better shape now. I think the fact that there's none of these methods are super long and none of them go super far to the right. And I think they're broken up along sensible boundaries. So I think I now stand a much better chance of being able to do something tricky, like introduce the identifier context. So, where do I want to start? So essentially the goal here is to avoid ever having to look something up. So like this. So at the moment, I'm having to store the local variables as this sort of association list where it's a list of pairs, names and values. What I want to be able to do is just store a list of values and be able to use slice here to just pull out the nth value, and that can all be determined at parse time. So what we need to do, where else do I use ASOC? Locals, globals. Maybe globals is more achievable in the first instance. I mean, locals shouldn't be too difficult. What we have to do is, I think locals are only introduced when you define a function. So what we need to do is in the parser, when we're parsing a function, we need to start keeping track of what are all the locals that are in scope at the moment. So that's the identifier context, right? It's like a list of, well, let's look at the, I guess it'll be in text format. The text format allows the use of symbolic identifiers in place of indices. To resolve these identifiers into concrete indices, some grammar production is indexed by an identifier context as a synthesized identifier context I as a synthesized attribute that records the declared identifiers in each index space. Right. So the identifier context is not just a hash or not just an array, say. It's sort of segregated into IDs that refer to types, IDs that refer to functions, IDs that refer to tables, and so on. So we need to sort of keep, each of these is just a list. And I mean, I guess, you can introduce local variables, for example, that, I think this is right. You can introduce local variables that don't have names. You can introduce function parameters that don't have names, in which case they're only reachable by their index, their numeric index. So in these lists, there would be some nils in those places. So it's like if the first and third local variables in scope actually didn't have any names, you just have nils in those spots. But then when you wanted to find the index of the second local variable, which does have a name, you could go and look it up in that array and it would tell you the index would be, well, I guess 1, not 2. So this is the data structure that we need to maintain. And I think as we parse, so for example, if we parse a function definition, that introduces new local variables. In fact, the parameters show up as local variables as well. So we need to sort of have some state that either we need to store some state on the parser or we need to thread through this identifier context and sort of modify it as we go and pass it down into every parse method. Do I want to do that? I'm not sure. Maybe I'll see how far I can get with passing it around as an argument, but it might be something that we need to store it, just for my own sanity. We might need to store it on the parser as a piece of state that's always implicitly available. And then when we want to modify it, do something like, in the same way that we've got read list, that effectively saves the old version of the state and then yields to a block after updating the state to be some new thing. Maybe I could have a version of that for the identifier context that's like with context do, and you give it a modified identifier context that's got all the locals of the function in or whatever, and then inside that with context block you evaluate the body or whatever. I think I'm going to start out threading it through, and then I'll do a refactoring to move it onto the parser state if that feels like it's necessary. So so I suppose here is the thing where it's like, when we find a local.get or a local.set or a local.t, this index is supposed to be referring to, well, parse index could return a number. And it could return a string. So I just paused there because I was thinking like, well, maybe we actually want to pass the appropriate like list of identifiers into this, so that if it's determined that it's an ID, it could actually do the lookup right here. But maybe that's too aggressive. I mean, in this case, well, we're always going to want to look this index up somewhere, but where we look it up depends on what kind of instruction it is. Because in these cases, it's the index of a local. In these cases, it's the index of a global. In these cases, it's a label. I'm not sure where labels come into it. Maybe they don't. Yeah, I'm not sure about that because I don't see how that fits in here to the identifier context. Oh no, look, in the identifier, I don't know what I was looking at there. Labels. Okay. So hold on, let me just read this because this is quite formal, but let's see what it says. A module consists of a sequence of fields that can occur in any order. All definitions and their respective bound identify scope over the entire module, including the text preceding them. Right, that was the thing that scared me when I read it several hours ago. So that's clearly a worry. Yeah, I'm not sure what to do about that. We'll cross that bridge when we come to it. A module may bind an identifier that names the module. The name serves a documentary role only, so basically we can ignore it. So this is saying that a module consists of module, atom, opcode, keyword, whatever you want to call it, then an optional ID, which appears to just be ignored. And then it says 0 or more module fields, and the module fields are our friends, type definition, import, function definition, table definition, memory definition, and then some stuff we haven't looked at before. And this is saying that the interpretation or the synthesized attribute for each of these is an identifier context. I think. Because this types, funcs, tables, mems. These are all fields of the identifier context. And it says to avoid unnecessary clutter, empty components are omitted when writing out identifier contexts. So these are all identifier contexts. It's saying effectively the result of parsing a type definition is an entry in the identifier context. And the result of parsing an import is an entry in the identifier context. So at the moment, all of this stuff that we're parsing well, I don't know how seriously to take this, but this definitely suggests that it definitely suggests that really the result of parsing a module is an identifier context, because each of these fields, when you parse a function, you get, what do you get in this funcs? Vector of func. Oh, hold on. I was misreading. I'm sorry. Right. So this is an identifier context, which is a record that contains fields that are labeled with types, funcs, tables, and stuff like that. But that's different from here. These aren't identifier contexts. These are modules. Right. Okay, that makes more sense. Okay. So when you parse a module field, you get a module back. So this is saying you get effectively a module containing a single type definition, or a single import, or a single function definition, or whatever. Okay, so this actually isn't about identifier context, I understand. But this is saying that when you parse a complete module with all of these module fields, I think this is sort of pointwise composition. Yeah, the composition of a sequence of records. If the sequence is empty, then all fields of the resulting record are empty. R1 circle R2 denotes the composition of two records with the same fields of sequences by appending each sequence pointwise. Right. So if you've got fields foo and bar in both records, then when you compose those two records together, you get a record that's got fields foo and bar, and you've concatenated the lists of their values to make the new value of fields foo and bar. So this is just a long-winded way of saying you go through the fields, each one of them turns into like a mini module, and then you compose all of those modules together to get the final one. But then there's this thing here that says I equals, effectively there's this IDC function here that also produces, this is why I was confused, it also produces an identifier context for each of these things. So each module field, in addition to producing a little mini module and that all get composed together to make the final module, it also produces an identifier context, and those all get composed together to make the final identifier context. So this is the definition of this IDC function. Uses the following auxiliary definition, which maps each relevant definition to a singular context with one possibly empty identifier. So this is like another... at the moment we just parse all of these fields to get, and we sort of smush all of these together at the end to get the module. I mean, effectively, this thing here is our text fields. Yeah, this is effectively what we're doing, is that we are sort of separately collecting these sort of, they're not represented as modules, but like these pieces of modules, and then we smush them all together. Well, we smush them during the iteration actually, and then we combine them all. But we could just as well have a single hash here, and that we're modifying as we go around this, or we could produce an array of hashes that we then sort of use inject to squash them all together at the end. So we're kind of already doing this part. But this is saying that we need to be able to right. So we need to have this sort of initial identifier context that knows about the IDs of all the things being declared here. I was pausing for a second because I was trying to figure out where the local variables are, but I guess they're not. Like at the module level, you just have all the IDs of all the type definitions, the IDs of all the functions, the IDs of all the tables. And then when you go down into a function definition and start parsing the body or whatever, at that point you're going to need to add to the identifier context things like, well, exactly the parameters and the local variables of the function. But yeah, okay, this suggests... So this is a little bit awkward because it means that... Well, I would say it's very awkward. Because it means that it's not impossible, but it makes it more difficult for us to parse the module in a single pass, because the naive way of doing this is you would sort of need to pass over the module once to collect all of these identifiers, and then you can build your initial identifier context, and then presumably when you actually parse it, you need that identifier context that's complete. It might contain forward references or whatever. You need that whole identifier context in your hand so that when you're inside a function body that is referring to a particular type def or a particular, I don't know what else, global, like you can go and look that up in the identifier context, even if that appears later in the module, because you've already sort of collected the identifier context. So, and I mean, there are other ways of dealing with that. But I'm going to have to see how far I can get with it. Okay, so I'm sort of glad I read that, but also it's a bit intimidating. And also quite a lot of formal detail, which I accept is not particularly interesting to hear about. So how about I just do some hacking instead? So let's say... let's just start chipping away at local variables. Let's say we want to make it so that in the interpreter, when, well, I don't know, maybe globals are easier. Let's try doing globals first, because they do seem like they're going to be less complicated, because I think this is the only way to introduce new globals. So how am I going to do that? No, let's stick with locals. Let's stick with locals, because using globals means I have to address that whole two-pass thing. Well, maybe that's... Okay, sorry, I keep going back and forth, but maybe that's a good reason to do it. Okay. So the goal is to make it so that we don't need to do this. The change on this side would be only use slice, keep globals in an array, not an ASOC array. So that's the intention here, is that we should be able to, well, that would look like stack.push globals.slice index. That's the code we want to be able to write here. And the reason we can't is because index isn't necessarily a number. It could be a string that we, at the moment, we're having to keep track of all of these globals and look them up. I assume there's some kind of... Where do we even get globals from? Oh, right, we get them from parsing the module. Yeah. Oops. So this is going to be something like self.globals equals this globals.map. We want this to be to do value. We don't want to remember the name of the global. We just want to have an array full of values that we can then just straightforwardly index into with slice. So that's what we're trying to achieve here. So let's say if opcode, let's do a case opcode in global.get or global.set. I want to look it up in the identifier context. Let's say like context.globals index. So I guess this is also if index is a string. So this is gonna the intention here is to look up. I mean, I'm just inventing all this. I don't have any of this. Assuming there's a identifier context, it's going to have a globals index space that's just a list of all of the identifiers of the globals, some of which may be nil if those globals don't have an identifier. And then this index, if it's a string, it must be one of those identifiers, because I think in parseIndex we just let it back through. We don't do anything to it. And yeah, index here is there's a bit of index overload here, but index is the Ruby method that lets you ask for the index of a thing in an array. So that's what I'm going to try to do. That's obviously not going to work because those objects don't exist. So where's the first? Let's just find a test that we can run to provoke that failure. I32. Okay, clearly doesn't work. Oh, else. Well, I guess what I'll do is this. Of course, I've sort of got to have a catch-all there. Okay, so that wasn't a real failure. That was just me forgetting how pattern matching works. It's gone a surprisingly long way before it even tries to use a global variable, but I suppose this is the order that I got the test passing in, so I didn't have globals for a while. Okay, BR. Okay. So let's see how this works. Right, so this does have a few globals in it. So let's think about how am I going to do this? Presumably the error is that context object doesn't exist. Yeah, undefined local variable on method context. So, well, this is going to need to take a context. And then there's going to be a load of complaining. 330. So we're going to need a context here. Well, let's just chase down all of the... Oh, yes, well, there is the problem. Um, 306. Okay. So when we parse instructions, we're going to have to provide a context, which we are not doing here. Okay, so this is one place where there could be a sort of... I mean, for example, I know that we're going to need to modify the local variables part of the context to include the parameters and results. So this is one place. Oh, and the locals, sorry, the parameters and the locals is what that contains. So this would be a place where we would add stuff to the context, but we're going to need to get one passed into us. So here we need to provide a context. So at the moment, these four things I don't think are going to have any demand for a context. So let's just make it nil there. Missing keyword context 352. Yeah, we need to provide a context here, and we'll need it here. So we'll need to pass it in. So now here we need to provide it. And that means we're going to need to take it as an argument. This is why I was slightly reluctant to do the threading through, but I think this is just what is needed, at least at this stage. Okay. Yeah, I mean, maybe it would have been easier to store this as state on the interpreter, right? Okay, so we need to provide it here. So we need to pass it in here. This will eventually bottom out because there are finitely many methods in this file, but I know it seems like it's never going to. But the thing I like about chasing the exceptions like this is that you don't have to speculate about, you know, I just added one use of that context in the place where I need it, and now it's kind of, you know, the Ruby interpreter is sort of doing the sort of data flow analysis for me and just finding all of the callers that need to provide that stuff, and then I just get to mindlessly bounce off it. Context. Okay. I mean, arguably there are quicker ways of doing this, but this is by far the most mindless, and thus I prefer it. 290. So we're definitely going to need that here. The stack trace is getting a bit shallower. That's good. Oh, turns out. So why do we need context for parse global? Oh, because it has a value, and those instructions might refer to functions or other globals or whatever. Fair enough. Yeah, this is actually an initializer for the global. That makes sense. I would not have immediately remembered that. Good job. It's all explained in code. So now it's just complaining about the fact that this object's nil. So I think that might mean that I've successfully threaded it through everything. Let's make a speculative commit there of everything except the use of it. So this is, yeah, I mean, if the context is going to be cooked up anywhere, it's going to be here, because that's what this is. That's what this was saying, is that the initial identifier context is made from by applying this IDC function across all of the module fields. So this feels like the right place. It shouldn't be an argument to parse text fields, because the caller of this can't possibly have that information. Like, you get that information by parsing the fields or doing something with the fields. So this feels like the right place to originate the context. And then it looks like, I mean, I don't know if this isn't going to be all the places that need the context, but this is all the places that need it for the thing that we're trying to do, which is to be able to read, to be able to find the global, find the index of a global, which ultimately just means getting it into parse normal instruction. Like, that's what this commit is doing. Thread a dummy identifier context through from parse text fields to, what is it? Parse normal instruction. So this is well, let's just say thread through to thread a dummy identifier context through to parse normal instruction. We want to use the identifier context to look up the index of a global. So we need the context to reach all the way from parse text fields, where we're expecting to compute the initial context, and then I can link to this. Not very well. To the parse normal instruction method, where we parse the global.get and global.set instructions. Passing the context, passing the identifier context around is already inconvenient enough that we'll probably want to store it as state on the parser object instead, as we do with the current S expression. But I'd like to get something simple working first. Yeah, I'd like to get something simple working first. Okay, so all I've achieved there is just threading a nil through loads of method calls. Now I have to figure out what goes into this context. Like I said, it's really difficult because, well, maybe I don't need to worry about this yet. I was worrying about forward references, but actually maybe it's fine for me to... Maybe it's fine for me to try and get something working. So let's say... Okay, I'm not sure what this context is going to look like. Context equals data define globals, right? And then this is going to be context.new globals is empty. So that will make that error go away. Oh, okay. We've not finished threading it through. It was just being masked by that error. Context. 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 Oh dear. Context. Now this needs context. What? Hold on, this is going too far. Why does this need... These don't have access to that kind of thing. If you want to... Parse invoke. I sort of think that how do we want to deal with this? I mean, this is just rubbish to do with the test script syntax. This isn't really a WebAssembly problem. You know, when we're invoking this, I mean, I suppose eventually this is going to have to be sorted out. Because in the same way that we're expecting references to, well, but functions, this is different. This isn't like it's not like a $ID. Like, this is an export name. So why does it need this? Parse instructions. I think that we should be... I think these instructions that appear inside an assert return, inside an invoke, I think they should probably exist in an empty identifier context because they're not inside a module. So I think the threading through here was too keen. I think this should be something like... Well, hold on. Let's think about this. Does it work this way? I've actually never tried this with foo equals data define bar baz do def foo foo.new foo. Oh. Okay, so that does work. Can I, like, what I really care about here, in this case, is can I override the constructor with default arguments here, and then make this be super? Yes. Okay, because that's what I think I want to do here, is because I want to create an empty context down there rather than make a class method or something. I think it might be easier to just make it so that these are all, that these default to 0, default to monoids, the empty array. So yes, I think that's okay. And then down here, I can just say context.new. So I'm sort of intentionally, explicitly doing it in an empty context. So again, parse expecteds. This is also happening inside an assertion. So again, I think this is going to be context.new. I really don't want that to be the default I don't want that to be the default when calling parse instructions, because then I'll never find the places where I need to provide it. How can this be parsing? That's not possible. I haven't implemented it yet. Okay, good. We have an actual failure. Oh, okay. More of this. Okay, so we're a long way from finished with the threading through. We've just got to find all the... And of course, this is the unfortunate thing about not having a static type system, is that I've got to do this sort of dynamic analysis rather than allowing it to happen statically. Surely these are going to need them because they ultimately call parse instructions. Okay, let's find where else needs it. Wow, okay. Let's keep going. I really hope that there's... I'm really confused about what's going on there. Like, how on earth? I'm not making any attempt to make this work. Maybe it's somehow using nil as the identifier successfully. Anyway, thankfully, brif is blowing up. No matching pattern error. Okay, something's gone quite wrong there. But let's... well... Let's not add that just yet. I'm not sure what to do about these. Maybe I can fake this with a nil for now. Okay, I think that is all the threading through. In fact, maybe what I can do is what I could do here is just make this a dummy, like instead of nil, make it just that. Because I don't, there's nothing about globals in here yet. And just allow these to be empty context. And then that shows, you know, we make a dummy one and then we thread it through. And it shows where we insert a dummy one. So inside parse invoke and parse expecteds, I've chosen to provide an empty context. Or like, yeah, I've chosen to provide an empty context because those commands, because the relevant commands only appear outside of modules and hence shouldn't have any identifiers in scope. Okay, and then I can at least say add globals, what does it call it? Index space. This is one of many index spaces which hold the identifiers for certain kinds of definition. Okay. All right. So if I just take this out, that test is fine. Well, maybe this is, maybe I need to fail fast here, right? Because if I read off, if index returns nil, it's just gonna silently plop a nil into my program. Unhandled exception, right? So we need to arrange for the context to have the right information in it. I think the way to do this, for now, is to enrich the context at this point. So I can add the global to the modules list of globals, but I should also be able to add. So for now, let's just say, because this isn't a local variable, context equals context.new globals context.globals plus global.name. Is that a thing? Ah! It works. So, all right, okay. So this is all very silly, but we're getting somewhere. So this is add new globals to identify a context as they are parsed. So I don't think this is going to work in general, but in this particular case, it seems to work okay. Let's run all the tests and see what happens. Do I have anywhere where the globals are defined like lexically after the point where they're used? Because if I do, it's not going to work. But I'm just trying to get my first foot on this, on the first slippery rung of this ladder. Okay, great. So that means I can add this because this actually doesn't break the tests. So this is lookup global identifier in identifier context during parsing. This means that we only have numeric indexes for globals once they have been parsed. So we don't need to keep track of global names in the interpreter anymore. So now I can do these to-dos in the interpreter, one would hope. I think instead of that 2-item array, I can just be the value. In fact, there's a temptation here to just do this. Here, I'm going to try to do this. Oh, and here as well for set. What do I want to say? Globals index equals stack.pop. It's a bit annoying, the square bracket situation here. Could I use splice? No, that's not a thing. I'm thinking of JavaScript. Does not modify self. Yeah, okay. Wow. Imagine wanting to write this in JavaScript. So just a single value. Well, let's try float expros. Okay, that is promising. Let's run everything then. Because this raises the tantalizing possibility that if the interpreter doesn't need to know, the names of globals anymore, then we actually don't need to store them on the AST nodes anymore. But unfortunately, that is currently, there we go. That is currently how the parser is getting them. You know, it's by looking at global.name. So we'd sort of need to break apart the two pieces of parsing a global. Like we make an AST node for it. I can't think what you put in the AST node. Oh, I guess the original value. Yeah, we need to. It's an initializer for a global, so we need to put in the initial value. But we don't actually need to have its name anymore because the interpreter now never looks at the name of a global. you know, we used to say global.name here. Now, the only place we're doing that is in the parser, so that information doesn't need to be in that sort of stage computation with the disgusting connective tissue between the two parts, the two stages of the computation. We don't need to communicate the name of the global across that gap anymore. I was being quite careful to always give an argument to stack.pop, wasn't I? Maybe I should keep doing that. So it's like stack.pop1 into value, and then this equals value. And then this was, I mean, I'm not saying that this is necessary. This needs, I'm not saying this is necessary, but it's a bit of a distraction to see that change. So, you know, in this diff here, it's like, well, what was wrong with this? And the answer is, well, nothing. We just don't actually need it in a local anymore. We could have just done it in line. But I'll just leave it like this for now. Yeah, and likewise here. I think it makes the diff clearer. And then there's a separate question about in these various places where I'm passing 1 as an argument to pop, and then I have to destructure the array to get the value out. Is that really adding anything, or is it just me being silly? So this is replace. Is association list the name of a thing? I keep saying that, but I'm not sure if it's real. Yeah, there we go. Association list. Replace association list of globals with array in interpreter. Now that globals always have numeric indexes, we don't need to remember their names anymore. We can just store their current values in an array and look them up by index. Great. What's get delta marker? Syntax highlighting pager. What sorcery is this? Oh wow. Right. So this is kind of similar to, it's a bit like it's like that, but less disgusting. Yeah, that is quite nice. Well, I'm not going to get distracted by that, but I will consider get delta. Right, so is it easy for me to, I mean, it would actually be quite a principled transformation to remove the name from the AST node. Well, don't worry. I was only distracted for 10 seconds by that, and then as you can see, my laser-like focus has returned to whatever the hell it was I was doing, which I can't remember. Oh yes, removing the name from the global AST node. So That's what I want to do. However, I can't do that because of this. I mean, why don't I just bite the bullet and write a separate function to create that initial context? Because I know that this approach is not going to work. This is just a hack to avoid having to reparse the syntax of a global. What can I get away with here? Because at the moment, the style of the reason I'm thinking is that the style of this parser is that it's sort of destructively consuming the S expression as it parses it, and so it makes it difficult to do a sort of two-pass parse, because if you've taken one pass over it, you've destroyed it. So if I wanted a separate function that I could feed these text fields into and get an identifier context out, then I would either need to write it in a different style, so in that sort of non-destructive pattern matching style where you sort of match the array against the thing you're looking for, comma, splat, rest, and then keep iterating until rest is empty. Or I could just make a deep copy of the current S expression and sort of extract an identifier context from that. I think this is going to be temporary because I do know a better way of doing it than this, but I want to kind of, well, a different way of doing it that doesn't involve two passes. But for now, I just want to get something working. I mean, let's see how this looks. Look, like, okay. I'm gonna do a hack and say S expression is in global, comma name, comma star. And then we parse it, and then this just becomes name. So this is like add its name to the context, and then I can inline this again. You know, I'm just sort of peeking into the, well, in fact, what this will, yeah, no, that's right, I think. Yeah, that seems okay. So let's say read global name directly from S expression instead of not AST node. This is a hack, and I'll get rid of it before too long. But for now, I'm trying to create the opportunity to remove the name from the AST node entirely, since the interpreter no longer needs it. Okay. So now I think I can remove it. Unless there's something that's using it that I don't know about. Remove name from global AST node. The interpreter doesn't need to know it anymore because all references to global variables are now made with numeric indexes, not IDs. Okay. So is that actually true? It's also possible that there might be other reasons you'd want to keep the name on the AST node, but like for now I want to pair it back to the actual minimum that the interpreter requires, and then if there was some interesting reason to preserve more information from the source, like for debug reasons, or here we go. Oh yeah, right. That's true. The parser needs to know to no longer bother with the name. I mean, obviously here we could return like a pair of the name and the AST node, but that might be interesting actually. So this failed on br.wast. Float expres. Those are kind of my, smoke tests. All right, I think this is good. So I can just amend that. Remove name from global AST node. Okay. So that's good. Obviously I'm going to need to find a better way than this of finding the names of all the things. Although saying that, like when you look at this IDC function, it's pretty much just saying, well, it's whatever whatever comes after the thing here. It's different for imports, but actually I think I could probably get away with it for most of these, except for the fact that I don't think forward references are going to work. But I feel emboldened by this. What shall I try next? Maybe function IDs? Because they work basically the same way. So how would that work? I guess it's when you make a call. Oh yeah, okay. So it's in the same bit. Okay, yeah. So call takes an index as an argument. So let's say in call context.functions.index index or raise. Context, it's going to need functions. What order are these in? Let's try and reproduce what the spec says. So I'm expecting to get some kind of exception here because that list of function identifiers is always empty. So the first time someone goes to, well, the first time we've got a function call, we should see a problem, but I don't actually know where that is. Okay, here it is. All right, our old friend BR, call $dummy, call $f. Okay, so there is opportunity for these to be, for these to point at the wrong place. There's more than one function. Although I don't know if this is all in the same module or not. Yeah, it looks like it is. So fingers crossed, this is a decent test case. And yeah, currently not good. So let's try that same thing again. Let's say this is function. And also context equals context.new. Oh, okay, this is going to need to be... Okay, we clearly need to implement this. Functions is context.functions plus, what is it, function.name? Yes, and that's different from its exported name. This is sort of its local name within the module, so that's what we're interested in. And globals just need to be context.globals. Okay, so yeah, contexts obviously need the ability to be composed because this is going to very quickly become unmanageable. Okay, so let's see what happens now. It got further, because before not even a single one passed, but now it's got as block mid. Call dummy, BR0, call dummy. So what's the problem? (276) unhandled exception. What? Oh, it's in the interpreter. Oh, it's trying to look it up by name. Right. Well, we need to change that, don't we? Let's say function equals case function in string, do this, in integer functions slice index or raise. This isn't function, this is index. Same thing here in call indirect, but let's see what happens here. Okay, that's good. Let's see how much further it gets. But I mean, it looks like call indirect, the implementation of call indirect is going to have the same problem here, where it's expecting... I mean, if this is all working, then I don't need this. I don't need a condition here. I just need to switch it over to always just use slice. Oh, this is in the parser. So what is this? Call.wast. I think there's a decent chance that this is going to be testing forward references, but let's see. 520 and parse normal instruction. Okay, yeah, so it hasn't managed to find it. Let's put sexpression.inspect and let's push context.inspect. Push. Okay, so what are we trying to evaluate? Okay, so some of this has been fine. Here we've got a context with lots of... Oh. Why are these repeated? I32, I64. Oh, they're not. F32, F64, I32, 64, I32, I64. And we're trying to call FAC. Oh. If this is a recursive function, then that's going to be a problem. Call FAC I64.sub. Yeah, okay. Fair enough. Obviously, that's not going to be part of the identifier context. Well, why is that? Oh, because we have to parse this to get the identifier context out. To get the name out. Right, okay, so I think we're going to have to go straight to the hack here because you can't even parse the body of a function until you've got... So we need to do things this way around, right? So we need to say sExpression is equal to func followed by name, and then we need to... Okay, hold on. So this goes back in here. This goes here, and instead of function.name, we just say name. And then when we try to parse the function, we will already have the name of that function in the context. Still not happy. All right, although it's unhappy for a different reason. Call odd. Right, okay, so this is a forward reference. So this is what I was worried about. So now it's not good enough that we've bound this name. These are two mutually recursive functions, so it's not good enough that we've bound this name before we've tried to parse this one, because actually we haven't even reached that function yet. So I think this is the point at which I'm going to need to do something else. Because it's kind of sort of working, but it doesn't work in general. And unlike with globals, this test has specifically got places where IDs are referenced before they've actually been defined, and we've got to be able to support that. So I'm just trying to think of the easiest way. I mean, I'm fairly far down this rabbit hole in terms of implementation at this point. I haven't written that much, actually. So why don't I back out of this temporarily and think about how to do that for what I've already got. So I'm just going to sketch this out. So if I had some function foo, let's say that what we're going to do is context equals Um, so inside here, the shape of what I want this to be is repeatedly do. Read list do. And then consume. Basically, it's going to be like this. Except it's only global that I care about. Well, I guess let's say we have all of these. There's no particularly tidy way to do this. So it's gonna have this kind of shape. And in here, what we're going to do is we're going to say read global, read name, and then repeatedly read. So this is going to read the name, and then it's going to, let's say at the beginning here, well, let's say context.new.tap do. No, that's not what I want. Context equals context.new, and then we're going to return context at the end. And the reason I went, I don't want that is because this context is immutable, which I sort of want at the moment because it's going to make it easier for me to avoid silly mistakes. So let's keep this immutable context. And then here, what we're going to do is something like this, right? So this is, I guess all the rest of these are just going to be repeatedly read, because read list is going to check that we've consumed the whole list. So here we're going to why don't I just, for now, this is fine, isn't it? I mean, for now, I could make this case read, and then just, I'll probably want to change this back to peak if I end up calling helper functions here that have got that constraint, that where it's like, oh yeah, you're supposed to consume your opcode when I call you, but for now, when this is all in one, but this foo function is all in one place, this will do. So this one's just read the name, stick it into the globals context. Okay, this is interesting, because if I can compose these, I could, because it was repeatedly is essentially a map. So I could just return a context that only contains that name, and then I could do some kind of inject at the end to squish all of the context together, but I don't have a squish two context together operation yet. So this would be something like read list from, and then I want a deep copy of the current S expression, because this is gonna trash it. It's gonna shift stuff off the front of it. Oh, how am I gonna do that? I mean, I don't know a great way to deep copy an array apart from using Marshall. I mean, that is obviously very horrible. Let's just see what that does. Read list, no block given. Oh, yeah, I've got to call foo. Of course. Okay, well, this gets me a small amount of purchase on the problem, I think, because now, although it's really awful to do this, it does let me continue to program in the style to which I am accustomed in this parser, and it lets me keep using all my helpers and stuff. No, I think I prefer doing it this way around because that makes it easier for me to return this. Okay. So the only problem is this is called foo. I think it's also in the wrong place. Let's put it down here. What should I call this? So here, the definition of the initial identifier context. And they call this function IDC, which is really the function inside the loop here. Yeah, it's really this. What am I doing? Why am I talking about that? It's this. I was looking at the wrong method. It's that function. And then this kind of point-wise composition operator thing is mapped over the whole list. Okay, I just got to think of a name for this. Maybe initial context. Build initial context. It's like, it's not really parse, but it's also not really read. I mean, that's as good a name as any for now, I think. I mean, I really don't like this. I mean, obviously I'm making an assumption there that this matters. Let's see, if I just say read list from S expression, do. No, I mean, it's just removed everything from the S expression as it. And I think if I do clone or dup or something here, it's not going to be any better. Okay, that's actually worse. Yeah, because neither of those do a deep copy. So I think this fairly awful approach of round-tripping it through Marshall just guarantees that there's no aliasing, that the object I get out of this is a copy of the original object, but it doesn't share any of the... They're in two disjoint parts of the heap. So it doesn't matter if... Well, when the copy gets destroyed, it doesn't affect the original. Like I say, I think I can do better than this, but for now I'm just going to stick with something simple there just to get the job done. So let's say build initial identifier context from a copy of the S expression, from a copy of the module fields. It's pretty gross to use Marshall to take a deep copy of the S expression. Yeah, that's right, Marco. It sort of does a shallow copy. So if my array was like, hello world, and then I said copy of array equals array.dup, then you can see that the object ID of the first array is different to the object ID of the second array. So like they're different objects, but if I say, you know, array.first, if I concatenate something onto it, now array is hello world, but if I look at copy of array, that is also hello world, because even though it's a copy of that array, the strings are still the same. So if I look at the object ID of the first string, that is still the same as the object ID of the first string of the cloned, or the duped array. So yeah, and it goes one level deep. Whereas by using Marshall.dump of my array, I get this horrendous binary representation in, you know, probably MRI version dependent. No, it's not. But this is definitely like not a human readable representation of that object. It's been serialized into a string. And then if I Marshall.load that, I get a brand new array back. Where now, if we look at the first object ID, now you can see this is actually a different string than the one that came in, because it's been sort of reconstituted from that serialized representation. So yeah, if your array contains things that are themselves immutable, then taking a shallow copy is fine. But in this case, it's an S expression, so it's an array of arrays of arrays of arrays. And so each time I'm churning through those nested arrays and shifting stuff off the front of them and sort of, you know, consuming them, I'm destroying the original object. So that's why I need this annoying clone here. So I'm just gonna, well, I'll write in this commit message how I actually want to do this. It's pretty gross to use Marshall to take a deep copy of the S expression, but it's a quick and dirty way to get something working. It'll let me building the whole context up front makes it possible, not just easy, possible to deal with forward references, e.g. Calling a function before that function has been defined. Or let's say calling a function which is defined later in the module. It's pretty gross to use Marshall to decopy the S expression without destroying the original S expression. Once this is all working, I'd like to switch back to a single pass. Well, to a single pass over the S expression, rather than taking a deep copy in order to process. Well, let's say rather than processing it twice and taking a deep copy. I do this by making the various parse methods return an updated identifier context if they parsed something that affects the context, and a proc which can be called with an identifier context in order to finish parsing the rest of that. Well, in order to, it's not necessarily finish parsing, because actually I think you do all of the parsing, but you just return a proc that needs an identifier context in order to produce an AST node, This will allow us to collect up the final identifier context and then pass it into all those procs to get the final abstract syntax tree. But that's a bit complicated, so I'd rather build up, but that's a bit complicated and prone to, well, it's just a bit complicated, so I'd rather build up my confidence first by getting everything working and save that approach for a final refactor. So that's the deal, is like, instead of trying to actually parse it in one go, you almost parse it in one go, but you end up with a load of unfinished computations to actually produce the AST nodes. And you've sort of done all of the lexical part of the parsing, but there's a bit of unfinished work, which is looking up identifiers in the identifier context, which wasn't available at the time when you did the parsing. So instead of returning the actual nodes, you return procs that are waiting for the identifier context. And then once you've finished doing all the parsing and you've got the final identifier context in your hand, you just go and plug that into all the procs, and then those which need to look identifiers up in it can do so, and then produce the final AST nodes. So it's not that difficult really, but it's A, a bit hard to explain, and B, a bit difficult to get working at the same time as the other complicated thing of making sure that I'm actually updating the identifier context correctly and getting all the WebAssembly details right without worrying about the sort of Ruby level details. So I think I'm gonna stick with this nasty approach for now, just for the sake of being able to make progress. All right, we've got 10 minutes until the 100-hour mark, so I'm gonna set a 10-minute timer just so that I'm reminded of that auspicious moment when it arrives. Okay, so initial identifier right. Okay, so that now gives me a place where I can solve this function forward reference problem, which is what I was trying to do in the first place. I'm surprised it managed to auto-merge that, because that's not right. But such is life with Git. So these are the offending bits. So we've added globals to the context. That's going to mean, so here we're going to say read name. Then we're going to say repeatedly read. And then we're going to say context equals context new context.functions plus name globals context.globals. Yes. And then, yes, that is actually correct. So what's happening here? Hold on. This shouldn't have been here anymore. That was a mistake. Let me just check that I just forgot to remove that. Yeah, so rather than doing it inside parse text fields, it's now being done out there. Yeah, okay. It wasn't doing any harm, but it also wasn't correct. Okay, so now... Okay, so let's see. What is this change? So we're adding functions to the context, and then now we're reading the name of the function and we're adding it in the right place in the context. So now I'm sort of hopeful. Oh, let's take that puts out, because otherwise that's going to make a right mess. I mean, I'll need it again if this doesn't work, but let's see it fail before I sit through all that debugging output. No major incidents yet. Wow, great. Okay, so, well, if that's really working, these are all going to need to be separate commits, but if that's really true, then I don't need this conditional anymore. I should just be able to do this. I wonder why I'm not getting any failures relating to call indirect. Is it because, yeah, okay, it's because I need to look up the I'm actually not sure how this works, but I assume that what I need to do is when I'm putting the table together, I need to dereference all of the function IDs and turn them into indexes, because it looks like this is coming from the elements of the table. And then, yeah, if this was always an integer, then again, this could be slice rather than detect. Okay, so what have I actually got here? Let's get rid of these because they seem to not be necessary. Okay, so let's... I think this is the first thing, just adding those in, because even that affects... You know, we have to account for that when we're creating a new context. So the fact that you need... Well, I mean, I guess this is always going to be empty at this stage, but this is the correct way to add another global to the context, is to leave the functions index space alone and then append a new one to the global's index space. So let's say add functions index space to identifier context. And then well, what do we want to do? Add function names to identifier context, initial identifier context. And then I think these two changes go hand in hand, which is like, what did we say before? Look up function identifier in identifier context during parsing. So I think this is probably clear that like when we do that on this side in the parser, now we have to handle the name differently on the interpreter side because it's no longer a name, it's just an index. So how does this work for call indirect? Because otherwise we'd be able to get rid of the function names. We still need their exported names, but we wouldn't need their sort of module local names anymore because they would have that would have gone away. Call indirect. Let's just have a look at what this says. So that's control instructions, call indirect, table ID, type use. So it does kind of seem like the problem is the elements in the table, as I said before. So I think it's maybe not call indirect that's the problem, it's table. So what happens in parse table? Because here we should be able to tell, yes, that this is a func ref. So this is a table of function references. So let's have a look at tables. Table definitions combine a symbolic table identifier. Right, we're not worrying about table identifiers at the moment. An element segment can be given in line with a table definition, in which case its offset is 0 and the limits of the table type refer to the length of the given segment. Right. So an element segment is what we're actually talking about. Element segments allow for an optional table index to identify the table to initialize. So yes, that we don't have that when we're inline. Oh, that's my 10-minute timer. Well, basically, as soon as we get onto the next minute, it's going to be 100 hours. So that's a terrifying prospect. I'll give it 30 seconds and then I'll do a celebratory whoop. So it's really the element list that we're interested in. So this can be, this ref type can be funcref or externref, and then this can be elem_expr, and it says type t init y star. What's init? Oh, the initial contents of a table is uninitialized. Oh, we're down the rabbit hole here with respect to, okay. I think that's probably, I think we've probably crossed over into the realm of 100 hours now. So, whoop! Welcome to the second 100 hours of this project. May there be many more 100 hours of mind-numbing tedium of watching me doing computer programming. All right, that's enough celebrating. Calm down, everyone. Got work to do. I An element segment can be given in line with a table definition. So let's just see what syntax are we in here? Table, some numbers. Oh yeah, this was the limits, right? And then the ID. I think. I've already forgotten how this repeatedly until we're not matching a number. I literally just wrote this code and I can't remember. Just looking at this makes my brain hurt. Oh, actually, this is the wrong way round. That's why it makes my brain hurt, is that the optional ID comes before the table type. So it should be that way around. Then we get the limits and the ref type. So that was just a silly mistake. Well, let me run the tests, but I think that was an error. I mean, goodness knows how that was ever working. I mean, this is probably going to fail, and then it turns out I've misunderstood it. But it is, if that was a mistake, then it is concerning that I don't have a single test that picked it up. Yeah. Oh, okay. Well, thank you, Marco. Marco says, I have to say, I really love the extended format to see the whole process. That's very kind. Thank you for saying so. Well, I hope you stay tuned for until the 200th hour. This is a fully extended format. Real Lord of the Rings director's cut. Yeah, so this was just not right, and that made me confused. So let's not do that. I mean, it must just be the case that we don't have, because both of these are optional, the limits are optional, the ID is optional, we just must have got lucky that there is not yet a table that's got both of those things, because if they were both there, the parser would have blown up. So let's say parse table ID and limits. Parse table ID and limits in the correct order. I had these the wrong way around. But apparently we haven't yet tried to parse a table that has both an ID and limits. So it hadn't caused a problem yet. But the code did make me quite confused when I read it. Okay. All right, well, what was I doing? Oh, yeah, I'm trying to understand if and when we look these up in an identifier context. I don't know why I'm hoping that this is going to enlighten me. But this is looking for table, an ID. So, I mean, it looks like a fairly conventional table, but then it says, then read funcref. So I think it's saying there's an inline. Yeah, in fact. I mean, is it possible to have this inline? Is it even possible to have limits with these abbreviations? It doesn't look like it. I'm very confused about what is going on here. Why did I even need this? I mean, it feels like it was extremely recently that I needed it, but I can't see how it's possible to have these limits and also the inline element segment, unless there's some other class of abbreviation that I'm missing. Okay, yeah, I remember now. Stack.wast. Table 1 funcref. So what kind of table definition is that? Oh, it's right. Okay. Okay. Right, that makes sense. It doesn't have an inline element segment, but table type, but it doesn't have the ID is missing, and then the table type has got a limit of 1, and then the ref type here is funcref. Okay. Blimey. All right. Okay. Fine. So we do need that. It is in the right place. Yes, it is in the right place because that table doesn't have an ID. But if it did, it would come before the limit. Okay, am I any closer to understanding this? So, okay, so if we've got multiple elements, then we've got table ID ref type, and then it says LM, which is what we're doing here, if indeed there is such a thing. And then we repeatedly read. So here we get a vector of element expressions. So really I need to look at element segments to understand whether these get looked up. So this says a vector of element expressions or a vector of func IDs, which I think is what we're dealing with here. But how do you, I don't understand how you tell the difference. So func ID is just a number or an ID, which is what we're going to look up in the identifier context. What's an LM expra? Oh, item. Right. Okay, well, that's not what we have. We don't have items. So we must have function IDs here. Okay, so a table is basically a table of function IDs, it seems like. So what's the synthesized attribute for these LM element segments? Element segments, blah, blah, blah. So this doesn't say anything about looking it up in the identifier context, unfortunately, which is what I was hoping for. Now I've lost where I was. Tables. LM table ID 0 vector of function IDs. I I just don't know how to read that. I mean, I suppose this doesn't really matter. I was just hoping to find some advice in here about when to involve the identifier context, but I can't see anything in here about this LM table ID. What does that even mean? Like, this says element table ID and then something. Oh, I guess this is table use? Maybe? What's table use? Yeah, okay, it is. That's table use. So it's this form. Table. So we sort of define the table and then element table ID 0. And then a vector of function IDs. Oh, I've just realized this function ID, this does have the, this is what I was overlooking, is that this does have a synthesized attribute here that is look it up in the identifier context. That's what this means. So I've been looking in the wrong place all along. I'm sorry, that was very silly. I was just sort of, yeah, I was expecting some lookup to appear in this, but actually it's right here. So, okay, so that is evidence for my belief that when we put these function IDs into the element segment as part of the table, we should be resolving them in the identifier context because we know their functions. I don't know what this LM Expra item business is about, but I don't think I've seen, clearly we haven't seen that kind of table yet. So parse table, well, let's do the demand driven thing again. Everything that gets read here is a function ID. So instead of read here, what we want to do is do context.functions.index of read. So that's going to require this to get a context. So that's going to require this to provide a context. So that's going to require this to accept a context. And that means we have to provide the context here when we're parsing a table. So that was, sorry, that was rather protracted. But I think that's correct. Oh, and now I would expect this to break actually, because the interpreter doesn't know about this change, so it's expecting to get function names. So I think that detect is going to fail, and we're going to get unhandled exception in the interpreter on the line where we were doing the detect. Yeah, which is exactly that one. So that's failed successfully. Let's replace it with slice. And now the two pieces should fit each other. Oh, our 101 is going all right so far. So hold on, what have I done in my extract some helpers, tick, combine parsing and unfolding, tick, at least begin to introduce an identifier context, tick. I haven't looked up indexes for local.get. Trailing label correctly, tick. I think I did this one, sort of. Yeah, I'll take that. Oh, damn, it's not working. Oh, well. Okay, so call.wast. Unhandled exception. All right, what is the nature of the unhandled exception? Maybe I should put messages on my exceptions. Oh. Some stack discipline hasn't worked properly. Oh, hold on. Hold on, this change I made was wrong. This index, this is called indirect. So we get an index off the operand stack. We find the appropriate table. That was an immediate argument to the call indirect instruction. This was saying name, but actually it should say index. We look in. Yeah, it used to be that we got a name, but now we get the actual function index. So yeah, this is a little confusing because that index local variable is being used for two purposes. Can I make that any clearer? No. Yes. All right. Unfold and parse together, I've done. Okay. All right, I was just doing that to kill time while I wait for the test to run. But I'm fairly confident that this is correct now. Yes, there we go. I think I have to do this all in one go, because otherwise there's no way to make it work. Maybe I can say, let's say, that's just threading through the context. Thread the identifier context through to parse table. We need to look up the elements, the values in the element, in the table's element segment are function names or function IDs. So we need to look them up in the identifier context to turn them into indexes. We can't do that until we have access to the context. Okay, and then this next change, that's the significant change, is smaller. So this is just look up table elements in the identifier context. And so this is like, this means the interpreter no longer needs to use the function name, needs to find functions by name. I think that's true. Only there's no function.name anymore. There's only exported name. So that suggests to me that we could now remove that from the AST. So let's get rid of the function name. Lose that there. That's the name, but we're not using it anymore. I think that should be it. Remove name from function AST node. As with global earlier, as with global in an earlier commit, the interpreter no longer needs to know the names of functions because they're always referenced by index, numeric index. Okay, so we're making some progress on the identifier context after, I mean, this is why I was working my way up to it, is because it's actually a little bit gnarly. I mean, I think this is the worst of it, needing to build the whole context ahead of time is the worst bit. Let's make it so that we can compose these contexts a bit more easily. So let's say def plus other. How would this work? I would say context.new functions plus other functions. Okay, this is going to need to be globals. Why can't I type globals? Other globals. So that lets me compose, just plug together these two things. Are there any, I think there should be some well-formedness conditions on this, because you shouldn't be able to repeat an identifier, for example. Identifier context. Oh, it's just a sort of generic record. Oh, here we go. An identifier context is well formed if no index space contains duplicate identifiers. And then I remember that there was a well formedness constraint here that says you can only compose. So basically, there's an error. If you try to compose some fields together in such a way that the combination of their identifier contexts is not well formed, then there is no rule for how to interpret, how to parse a module. So what that means in practice is that I can just raise an exception if I mean, really, there should never be, you should never try to create a non-well-formed identifier context. So I think there should be some kind of, I mean, how can I check that? Can I do like that? Yeah. Yeah, I think this is array ampersand. Oh, whoops. That is not what I meant. I meant the quoted version of that doesn't put the process in the background. So what's the difference between that and array intersection? What? I think the only difference is the order. Oh, and also this takes multiple arguments. Okay, interesting. Well, I'd rather write the word intersection. So this should be something like raise unless functions intersection other functions empty and globals intersection other globals empty. So we want to make sure that these are disjoint when we join them together, because frankly, if we put an identifier on the end here that already appears here, it's never going to do anything, because whenever we're looking something up in the identifier context, we always look for the leftmost occurrence of that thing in the index space, which is because that's what the index method on array does. So we'd never search past it. So it would be at best useless to put another identifier on the end here, but it would also mean that your module wasn't well formed, because you'd have two functions with the same name or two globals with the same name or whatever. So basically you're not allowed to do that. So this lets us plug two contexts together now in a way that guarantees that the resulting context is well formed. So now can I just use that here? Oh, well, in fact, I can do the thing that let me do it a step at a time. I think I can say context equals context.new. Well, I think I can say context plus equals context.new functions name. And I think here I can say context plus equals context new globals name. So because the default for the other, here the default for the functions attribute is going to be the empty array, and here the default for the globals is going to be the empty array, that's going to initialize them to being empty. And then because we're just adding, we're gonna get this behavior where it leaves the globals alone and it adds the name onto the end of functions, and vice versa down here. So I think that's certainly a more acceptable way of writing that code if it works. So assuming that those tests pass, let's make this implement context plus for combining two contexts. Oh, it didn't work. Oh no. It's not well formed. Okay, let's see what's happening there. Func.wast. So does this at any point try to have two functions with the same name? Oh. Well. Well-formedness. I'm just thinking about nils. Like, what does this imply about... A context contains the list of identifiers. Unnamed indices are associated with empty entries in these lists. An identifier context is well formed if no index space contains duplicate identifiers. So I think we think about this as there not being an identifier if there's a nil. So I think this condition here needs to compact this to get rid of any nils first. Because otherwise I think it's a false alarm. No. Okay. Well, let's see what's happening then. Combining self-inspect with other inspect. So it's all been chugging happily along. Okay, well look, some of this is clearly nonsense. What's this doing here? That's not a function name at all. Nor is this. So something's gone quite badly wrong there. What have I misunderstood? Because it was fine before. Although I am now worried that there's still junk in there. Let's just see. Yeah, it makes me realize that, yeah, this code is not right, because if you look at parse function, it only gets the name if there is one, but I've sort of lost that. So I need to deal with that. And that's I think, yeah, I mean, I've accidentally saved my get rid of that stash because I've resaved it. And again, I think for parse global, I'll see this. So this one, what is the deal with globals? Let's see, text format. Globals. Yeah, I mean, the ID is optional here as well. So really, this should be, although it isn't there, I think where we know that an ID is optional, I think we should make an effort. So I think this needs the same. In fact, having seen that it is optional, I'm gonna fix it up there as well so that it's not misleading. Okay, good. That has solved the problem. So I'm not sure that the compact is necessary, or at least it wasn't in that case. Oh no, in fact it is. So we had both problems. Okay. Yeah, so you can see there are definitely nils in there. Yeah, so it's important that we don't freak out. You know, if there happen to be nils in both of them, that's absolutely fine, because that's not the repetition of an identifier. Okay, so hold on. there are several things going on here. Okay, one of them is that needs to compact. I can put that in a new commit. Ignore nils when checking identifier context for well-formedness. It's fine to repeat nil because that's the absence of an identifier. And identifiers are almost always optional. Okay. However, some of these changes I'm just going to fix up with earlier commits because it's not interesting that I got them wrong. So that func one, build initial context in astparser.rb. So I think it's that one. And split no, yes. So this one. I mean, it's essentially this one. But I'm not sure what happened before that. What did we delete? Yeah, I mean, that S expression was, yeah, that thing before was not right. But whatever. So let's do those fix-ups. That's okay. And then let's also, while we're in there, make ID optional in parse global. We haven't had to parse a global variable, an anonymous global variable yet. I mean, I think but the ID is optional. So we should be careful to only read it if it's present. So where do I want that to go? I think conceptually that lives here. So remove name. We do this, which is where we are sort of realizing that the ID is optional because in theory we're looking at the grammar at this point, and then we go and make it optional here as well. Yeah, I think that's good. Okay. So now what? Oh, yeah, right. So firstly, is everything unbroken right now? Yeah, because we're not calling that method yet. Okay, that seems to be okay. And now this is use context plus to combine contexts in build initial context. And again, I'll just let those tests run. I think maybe it would be nice to just add all of these contexts up at the end here. So instead of having this context.new here and returning context here and adding onto it here, I think I could just say inject context.new plus. I mean, that's pretty simple, isn't it? The only mystery there is, what about all of the branches here that don't return a context? Yeah, well, there we go. In order for that to work, I would need to say context.new in each of these. I think that's okay because ultimately these are all going to have to, they're all going to have to start working. They're all going to have to produce the context. So I don't think that's completely absurd. It's just at the moment they're all producing the empty context. So let's say use inject to combine contexts. In build initial context. This does force each case to return a possibly empty context, but they'll all need to produce one eventually, so that's not a big cost. Okay. What else can I do here? Because I've successfully removed names from functions and globals, I'm a little bit afraid, I must admit. Well, okay. I was going to say I'm afraid to do locals. And the reason I'm afraid to do locals is that they're a bit more complicated. I guess the upside is you don't have to pick them up at the field level because you can't declare any local variables at the field level. But inside a function definition, we have to make sure that we've... It just gets a little bit complicated, doesn't it? Because to find out what the locals for a function are, you have to look at the function parameters and the function locals. But the function parameters can come from a type def. So it just feels a bit It just feels a bit much to be getting into at 2 a.m. So maybe I'll cut my losses and sort of, well, I mean, are any of these other ones straightforward? And also, is there a way I can simplify this? Foo equals data define A, B, C. Foo equals foo.new A1, B2, C3. Does this have like members? Okay, so members are the names. Does it have values? I guess members is all I need. Define members new. Yeah, Marco, hopefully this is JavaScript's got a different set of problems than WebAssembly does with respect to scope. I mean, we don't have to I don't think we have to deal with closures here, or at least I haven't seen any. So that's good, because obviously arrow functions in JavaScript close over all of the locals that are in lexical scope, and then that turns into a huge nightmare. So yeah, I don't think we have to deal with that. It looks like it's only got members and to hash, but I think that's enough for me to do what I'm doing here. So here I want context new. Maybe I should just use to hash, because ultimately that's what I want to do. Yeah, I think that's a little bit nicer than using like send. There doesn't seem to be any way to programmatically get an attribute by name apart from sending a message to it, which is a little bit weird, because you can do that with struct. It doesn't look like there is any way to, apart from using to hash, there doesn't appear to be a way to say, because what I want to do is just iterate over all the members and do this for each of them, but there's no easy way to do that. So I think perhaps what I'm going to do here is say spaces, index spaces, well, foo equals, I want to merge these two hashes. So there's me to hash, merge, other to hash. Key, value 1, value 2. Raise and less, left, intersection right, compact, empty, left plus right. And then it's just context.new foo. I think that does the same thing. It's using hash merging. The block here gets called when there's a collision. So if you've got if you've got a key in the left hand and the right hand hash, then this block gets called with the values, and then I'm just doing the same thing with them. I think this is going to generalize better. So what do we say here? I'm not sure what to call them. Is that silly? Use hash merge to implement context plus more generically. This will make things easier as we add more index spaces. Maybe I'll call this spaces. Because that's, I think, what this calls it. I keep forgetting what they're. Strange languages. Yeah, index space. Okay, so let's overwrite that. Okay. So we're not looking at memories, we're not looking at tables, we're not looking at types, and we haven't even thought about locals. But I think I'm gonna leave it there because I would like to look at locals locals next. Let's make this look up some indexes and identify a context. And then the plan for next time is look up local variables in an identifier context. Identifier. Okay. All right, let's do the traditional celebration of our people. Just check this is all kosher. Yeah, I think this is good. All right, and now hopefully it's looking good. Come on. I reckon I can probably speed this up quite a lot, but it's obviously not a priority at the moment. Come on. Pass. Why are you taking so long? Yeah, there we go. Great. Very nice. Okay. Well, this never works. None of my keys ever work. There we go. There I am. okay, I think that's it. That's it for this time. That was actually pretty good. Thanks for the celebration, Marco. I feel a lot better now about the state of the parser. I know I probably said that last time, but like the having Unfold hanging around like a bad smell was really bothering me, and now Unfold is gone, so that's great. And I'm really happy to have broken the seal on finally getting some of the identifier context stuff in. Like, it's not all in, but I've started to chip away at it, which is much more than I can say for previously. So that's a relief as well. So yeah, that's pretty good. I'm sleepy, so I'm going to stop now. But like I always say, thank you very much for watching. I really appreciate your time and attention and patience and all of that. But for now, I will say bye. If I can press this button, the bye button. Yeah, thanks very much for watching. I'll see you again on the next one. Bye bye.